Synchronized Sequence. You heard Luce Fabregat just a moment or two ago explain some of the critical activities. The first one coming up just a few seconds from now, which will be the topping off of the main stage tanks. The first or core stage was loaded earlier this morning with 175 tons of propellant, 150 tons of liquid oxygen, and 25 tons of liquid hydrogen. The upper stage loaded with 15 tons of propellant. That will be the workhorse for a 16-minute burn to lift James Webb to its final orbit. At separation, some 27 minutes and 7 seconds after launch, James Webb will be at an altitude of about 864 statute miles. To put that into perspective, some 520 miles higher than the Hubble Space Telescope and more than 600 miles higher than the International Space Station. Webb at that point will be traveling about 21,000 miles an hour as it heads out to a highly elliptical halo-like racetrack orbit some 1 million miles from Earth to begin its scientific observations.
In a little more than 1 minute from now, we will see the 4 tanks pressurized at their flight level for the last tests before the ignition of the Vulcan engine. And in parallel, the electric system are also set in flight configuration, the onboard computer. The electrical power, as for the telescope, it will switch from ground to internal power 1 minute before the launch, 1 minute and 5 seconds before the launch. And we are going to see -6 seconds. At -6 seconds, we will see the disconnection of the upper stage, these big cryotechnic arms you can see on this picture. Then, 3 seconds before the H0, the inertial platform that will give all the information about where it is to the launcher will be released. And at H0, the 7-second sequence to ignite the Vulcan engine of the main stage will start. That will take 7 seconds, a little less than 7 seconds, where the engine will start up to its flight regime. Once the computer has checked that the Vulcan engine is running normally, and you will see at that point a flame going stable at the outlet of the nozzle, and at that point the onboard computer will ignite the 2 boosters that will enable to move the 770 tons of Ariane and Webb.
Coming up on the T-4 minute mark right now, just a couple of milestones real quick. At the 1 minute 5 second mark into the flight, Ariane 5 will go through the period of maximum dynamic pressure, max Q as it's known. That will be the period of maximum aerodynamic forces on the rocket itself. The solid rocket boosters, which will provide about 90% of the initial thrust off the launch pad, will shut down and separate at the 2 minute 21 second mark into the flight, followed 1 minute and 5 seconds after that by fairing jettison. That will expose the James Webb Space Telescope to the environment of flight for the first time. The main stage separation, or the first stage separation, comes at the 8 minute 47 second mark into the flight, and that will be about a 16-minute burn of that upper stage engine. It will cut off at about 24 minutes 51 seconds into the flight, and then we'll go into a coast phase of about 2.5 minutes to allow any oscillations to dampen out, provide the most pristine environment for the James Webb Telescope before observatory separation. We're coming up on the 2 minute 50 second mark into the flight. Again, you're going to be hearing critical calls down the stretch here from the DDO, or the Range Operations Manager, Jean-Luc Voyer. The weather is go. We have a green board, no issues being worked. NASA officials, including Greg Robinson on the right, carefully watching the telemetry, looking intently at the final couple of minutes of the countdown. Lives have been spent in the preparation of the James Webb Space Telescope that is about to fly.
And Beatrice Romero on his side, on the left of the screen, from Ariane Space.
And that is the DDO, the Range Operations Manager, Jean-Luc Voyer, as we have hit the 2 minute mark in the countdown.
The flight will be in two phases. You will see the first part of the flight during the solid rocket boosters phase. That will be the atmospheric part of the flight, the atmospheric flight, and the trajectory will be driven by a to reduce the aerodynamic loads, and we will have a very different exo-atmospheric flight after that.
And you were watching a number of people, VIPs and invited guests, moving out to the observation platform that is right next to the Jupiter Control Center as we stand by for the 1-minute call from Jean-Luc Voyer.
À tous les vidéos, attention pour moins 1 minute. Top, à 0 moins 1 minute.
Thumbs up from Jean-Luc Voyer. All systems are go. We're inside a minute now, T-minus 50 seconds and counting. As you heard earlier, the Vulcan 2 engine will ignite. Turbo pumps will come up to flight speed for 7 seconds, and the command will be issued to ignite the solid rocket boosters. The James Webb Space Telescope will be on its way. T-minus 30 seconds and counting. Standing by for terminal count.
À tous les vidéos, attention pour les décomptes finales. 10, 9, 8, 7, 6, 5, 4, 3, 2, unité, top.
And we have engine start. And liftoff.
Décollage.
Decollage, liftoff from a tropical rainforest to the edge of time itself. James Webb begins a voyage back to the birth of the universe. Punching a hole through the clouds, 20 seconds into the flight. Good pitch program reported.
Trajectoire nominale.
Vehicle performance is nominal. The Ariane 5 rocket continues to fly uphill in nominal fashion. The rumble of the powerful Ariane 5 now being felt here in the control center. 3D animation.
We can hear the noise and feel the vibrations here. You're right, Rob. Yeah, impressive.
13 kilometers in altitude, 7 kilometers downrange, traveling about 0.6 kilometers per second.
Tous les paramètres à bord sont normaux.
The trajectory reported to be nominal by Jean-Luc Voyer, the range operations manager. You can see at the bottom of your screen, the yellow line is the trajectory plot, perfectly overlaid over the green line, which was the pre-launch trajectory. 1 minute, 41 seconds into the flight, about 40 seconds away from shutdown of the solid rocket boosters. Coming up on the 2-minute mark into the flight.
When it detects the threshold on acceleration, not the deceleration, but less acceleration.
Tous les paramètres à bord sont normaux.
Everything is okay. Everything is normal.
2 minutes, 15 seconds into the flight.
When the computer detects this threshold, it will separate.
Séparation des EAP.
Done.
We have confirmation of solid rocket booster separation from Jean-Luc Voyer. This coming at an altitude of 44 miles. The Ariane 5 and James Webb traveling almost 5,000 miles an hour. We have about 1 minute, 5 seconds to go before fairing jettison. That'll be the next critical milestone.
The fairing is there to avoid the satellite being exposed to high temperatures and also high airflows. And as soon as the launcher leaves the atmosphere, as is now the case, the satellite does not need anymore to be protected, and Webb does not need anymore to be protected. So each kilogram being very important for the performance of the launch, we are going to eject this no more useful fairing.
And let's go down to the floor in the Jupiter Control Center to Raphael Chevrier of Arianespace. Raphael, so far so good.
Hi, Rob. So far, so good. Everything is nominal, as we say when attitude and trajectory of the Ariane 5 is going perfectly well. As you can see also on the yellow line on the screen, we had the confirmation of the separation of the two solid boosters and now of the fairing, meaning that we have crossed the limits of the atmosphere. So everything is going super good. And the DDO just said that all parameters are going perfectly smoothly. So let's continue the mission.
And Raphael, this is a view from the upper stage camera called the Vicky Cam, looking back at the James Webb Space Telescope. This is on about a 20-second delay or so because of the way the imagery is processed here in the control room. There's your telescope ready to unfurl its wings, basically, and begin its journey to the Lagrange point, the L2 point, about 1 million miles away from Earth.
La trajectoire est nominale.
Trajectory is nominal. The report from Jean-Luc Voyer. The liftoff time confirmed here in the Mission Control Center at 12:20 Greenwich Mean Time, 9:20 a.m. Peru time, 7:20 a.m. Eastern Time. The Ariane 5 and James Webb, 181 kilometers in altitude, 450 kilometers downrange from the launch site here in Kourou.
Flight control is very smooth.
5 minutes, 12 seconds into the flight. We have about 3.5 minutes to go in main stage or first stage performance. And again, you can see at the bottom of your screen the yellow plot line overlaid over the green line, meaning we are right on course, right down the pike, and a perfect trajectory so far for the Ariane 5 rocket.
All telemetry data are now received by the Galileo tracking station, which is close to here, where we are in Kourou. It will track the launcher up to the ignition of its upper stage, and then we'll have the natal station in Brazil, Ascension as you can see on the map, in the middle of the ocean, and the two last stations in Africa, Libreville and Malindi, one on the east coast, the other one on the west coast. And the one on the west coast, Malindi, you can see that the telescope will be separated more or less over this Malindi station. And this Malindi station will also acquire the telemetry data from the telescope. You can see both are green, Galileo and Natal, on this animation. It means they are expected to receive the data, and it was confirmed right now by the launch operations manager.
Acquisition de la télémesure par la station de Natal au Brésil.
And just confirming now that telemetry is being processed through the Brazilian tracking station. The telescope is also processing telemetry through the Tracking and Data Relay satellite system. As it moves further and further out into deep space, all of the telescope's telemetry and its imagery ultimately will be processed through the Deep Space Network in Goldstone, California. We passed the 7-minute mark into the flight. A perfect ride so far on the Ariane 5. We have about 1.5 minutes to go in the first stage performance. Once the main stage engine is commanded to cut off, it will be jettisoned, and just a few seconds after that, the upper stage engine will ignite, and it will be the workhorse for a 16-minute burn that will put James Webb into its preliminary orbit. About 11 minutes from now, telescope controllers at the Space Telescope Science Institute will be sending commands to prepare James Webb for the initial series of commissioning activities that will lead to the deployment of its solar array and the initiation of generation of electrical power for the telescope. About 30 seconds away from main engine cutoff.
La trajectoire est normale.
Nominal trajectory continues to be the watchword for the day from the Range Operations Manager, Jean-Luc Voyer, as we stand by for main engine shutdown and separation.
Extinction de l'EPC. Préparation EPC.
And we have main stage shutdown and separation confirmed here in the Mission Control Center and the ignition of that upper stage. And Raphael Chevrier down in the fishbowl. So far, so good.
Yes, Rob, we have the confirmation of the separation of the main stage and the ignition of the upper stage. The trajectory is perfectly nominal. This is a very important moment for us because it's always a challenge to switch on a cryogenic engine in space condition, and we are now at 220 kilometers of altitude. Speed is a bit more than 7 kilometers per second. As we enter now the second stage of the second phase of the flight, the upper stage is going to power for about 16 minutes to place Webb on its transfer orbit, and right now everything is again nominal as the DDO just said.
And a short time from now, the so-called Sawtooth Maneuver will get underway. Again, like rocking a baby in a cradle, this will be a maneuver to keep Webb's optics protected from overheating, Luce.
Exactly, Rob, like a baby in a cradle. You can see here Webb attached on top of Ariane 5 upper stage with a very specific configuration. Of course, it will be different during its lifetime, but for the time being, its sun shield is folded and not yet fully protecting the observatory. A number of exhaustive studies have been performed by the mission teams in Europe, in the US, on the thermal conditioning inside the telescope and the way the rays of the sun would propagate and interact with sensitive equipment inside the telescope. Maintain this thermal conditioning is really key before separating this telescope. And in particular, we know that one face of the telescope cannot face the sun. That's why and to produce these right thermal conditions inside Webb, a specific roll law has been designed, what we call the Sawtooth Approach. And if you are watching carefully to these images, you can see this animation. You can see that the upper stage is going 30 degrees on one side, then 30 degrees on the other side, going back and forth this way to maintain this perfect thermal conditioning for the telescope.
It's worthwhile noting that after Webb separates from the upper stage of the Ariane 5 rocket, which continues to perform in excellent fashion coming up on the 12-minute mark into the flight, the telescope controllers will be taking the baton, if you will, from the mission controllers here in Kourou. The first steps will be the opening of fuel valves, a pair of fuel valves, to start flowing fuel to Webb's onboard thrusters. They then will power on the valve drive electronics. Those are powered on in preparation to control and fire those thrusters when required. Webb's solar array is scheduled to be deployed at approximately the 33-minute mark into the flight. Once it is locked in place, we'll get the call that electricity is flowing through the array. That call will come from the Mission Operations Manager, Carl Starr, who is at the Space Telescope Science Institute at Johns Hopkins in Baltimore. Seated right behind him in that control room is Alicia Starr, a pair of stars helping to guide James Webb on its discovery of the stars. Alicia Starr is the lead engineer for launch and ascent events. Once the solar array is deployed and declared power positive, then 3 out of the 4 hold downs for the aft deployed radiator will be released to prevent binding due to the cool down of the telescope's composite structure. The contamination control heaters will be enabled to protect instrument optics on Webb from any water ice condensation as they cool down. The actuator drive unit will be powered on. This particular mechanism helps with heater control of the fine steering mirror, preventing water ice condensation, later to be used to position each of the mirror's segments. All 6 reaction wheels and the wheel drive electronics will be powered on for Webb, and that will be the precursor to the attitude control system using those reaction wheels to maintain the proper orientation with the sun, as opposed to using onboard thrusters. Of course, fuel in those thrusters, very valuable. It's a limited commodity for the lifetime of James Webb's observations of the universe. We're 13 minutes, 55 seconds into the flight. Jean-Luc Voyer, the Range Operations Manager, continues to report a nominal performance for James Webb. And again, Luce Fabregat from the European Space Agency, how is this trajectory being carefully and methodically adjusted to provide the correct parameters in the final stages of ascent?
Yes, Rob, as you can see on this plot, the altitude is slightly going down. It's perfectly normal. The launch vehicle is really on the line where it should be. This decrease of its altitude, slight decrease of its altitude, will allow the launcher to benefit and the upper stage to benefit of the gravity effect and to increase its velocity until it reaches a thermal threshold. It's about to reach it, or even already reached it now, and it will go up. And now it will go up and up to the separation of the Webb telescope. It will separate the Webb telescope on a highly elliptic orbit, but still around the Earth. The telescope will be released, inserted on an orbit around the Earth, with an apogee, a very high apogee above 1 million kilometers.
Trajectory nominal as reported by Jean-Luc Voyer. You see him in that view, 185 kilometers in altitude, some 4,500 kilometers downrange from the launch site here in Kourou, moving at more than 8 kilometers per second, right on the plot, right on the trajectory, everything looking great. We are about 9 minutes away from the completion of upper stage ignition, its shutdown, and then about a 2.5-minute coast phase before Webb will separate. Observatory separation will be called out. You'll be hearing those calls and the initial calls from Carl Starr, the mission operations manager at the Space Telescope Science Institute at Johns Hopkins, through solar array deploy and the declaration of a power-positive spacecraft. James Webb, of course, will be traveling well beyond the moon to a distance of about 1 million miles away from Earth, settling into a highly elliptical, halo-like orbit to begin its astronomical observations. And again, as we mentioned earlier, at the time of observatory separation, Webb will be at an altitude of approximately 864 miles, statute miles, traveling some 21,000 miles an hour. We're about 8 minutes away from upper stage shutdown. The stage has performed as planned. No issues reported. The launch occurring at 12:20 Greenwich Mean Time, 9:20 Kourou time, 7:20 a.m. Eastern Time on this Christmas Day.
Very smooth launch. The velocity you just mentioned is very important, Rob. The velocity you just mentioned at separation of the telescope is very important. It will be slightly below, okay, I give it in kilometers per second, but it will be slightly below 10 kilometers per second, because it's important that the satellite, the telescope, is not inserted on an escape orbit. It will be placed on a terrestrial orbit so that there will be time for the layout, for the early phase operations and the commissioning of the telescope. And that will be, in fact, the upper stage that will leave this orbit and goes toward an escape or liberation orbit.
And of course, even though we're still in powered flight, the trajectory, the acceleration, the speed at which James Webb is going towards its preliminary orbit, all modeled in advance and carefully choreographed to maintain as quiescent an atmosphere and environment around the telescope for its ultimate separation from the upper stage of the Ariane 5 rocket, which is about 6.5 minutes from now. "18.5 minutes into the flight. It's very quiet now here in the control center, here in Kourou. NASA officials, European Space Agency officials, Arianespace officials, all watching telemetry very carefully. And as the upper stage continues to burn nominally and sheds fuel, the acceleration uphill for the James Webb Space Telescope continues to increase as we approach the 20-minute mark into the flight. Again, upper stage cutoff is scheduled at the 24-minute, 51-second mark into the flight, about 5.5 minutes from now.
After the cutoff of this main engine, as you said, Rob, we will have a short ballistic phase, a short coasting phase that will, when the upper stage will rely fully on its what we call the attitude and roll control system, and it will adjust its attitude so that during this small ballistic phase, all the requirements from the telescope are fully met. And that at the separation, when there will be the separation, the conditions will be very smooth and as requested for the telescope. Beginning of life.
Today's countdown was as flawless as you can imagine. The weather was perfect all the way through the early morning hours, through the fueling process of the vehicle. The weather's been a bit dicey here in Kourou over the past few days, but everything fell together on this Christmas day to send a new present to the world's astronomer. 20 minutes, 40 seconds into the flight.
Trajectoire normale, tous les paramètres à bord sont normaux.
All parameters nominal as reported by Jean-Luc Voyer, the range operations manager. 4 minutes of powered flight remaining.
The telemetry of the launch vehicle is acquired for the time being by the Libreville tracking station on the western coast of Africa. Flight control is nominal. The trajectory is fully normal, fully as expected, as you can see on the plot with the yellow plot over the green one. That is the expected one.
22 minutes into the flight. Less than 3 minutes of powered flight remaining.
Smooth flight control.
And again, as we've mentioned before, everything nominal reported by the range operations manager. As we've mentioned before, this is a long ride uphill for the James Webb Space Telescope to put it at the proper position in the sky so that it can escape from the Earth, basically head beyond the moon towards its final orbit for its commissioning activities that will be the dominant feature of all of the operations from the Space Telescope Science Institute over the course of the next several weeks.
And the launch operations manager announced the acquisition by the Malindi station, as expected, for the end of the flight and the last part of the upper stage flight and the separation of the telescope.
James Webb is about 4 minutes away from separating from the upper stage. And again, at that point, it will be on its own. And again, those milestones that we discussed a bit earlier in the broadcast will begin to be followed carefully by the telescope controllers at the Mission Operations Center, the MOC as it's called, at the Space Telescope Science Institute in Baltimore. 1 minute of powered flight remaining. The upper stage continues to function perfectly. It's been a smooth ride for the James Webb Space Telescope.
Trajectoire est nominale.
That upper stage was loaded pre-flight this morning with 15 tons of propellant for this long 16-minute burn, now about 30 seconds away from upper stage cutoff. And we're standing by for upper stage shutdown and the cutoff of the upper stage engine.
Extinction ESC. Tous les paramètres à bord sont normaux.
The extinction of the shut-off of the cutoff of the engine was confirmed exactly as expected, with the exactly expected altitude and speed and velocity. So now we have entered the coasting phase, the ballistic phase, that will last for a little more than 2 minutes.
And the telescope controllers in Baltimore confirming that all of the function parameters for the James Webb Space Telescope have been loaded on board the telescope. We are expecting Webb separation at the 27-minute 7-second mark here into the flight. Just over a minute from now, springs will gently push Webb away from the upper stage of the Ariane 5. As it moves further and further away from the upper stage, there'll be what we refer to as a collision avoidance maneuver.
Yes, Rob, exactly. The springs already will give some distancing, of course, between the two objects, between the telescope and the upper stage. And then the upper stage will leave the trajectory of the telescope and makes a special maneuver to pass the telescope and heads towards a liberation orbit and leaves the telescope on its orbit without any risk of collision and without any risk of pollution towards the telescope.
And we're about 17 seconds away from Webb separation.
Séparation Webb Space Telescope. Go Webb!
We do have confirmation of observatory separation. The James Webb Space Telescope, amidst applause here in the Mission Control Center, now taking its first steps in pursuit of cosmological discovery. It was a perfect ride to orbit, and all of the separation sequence events are running in good fashion according to the telescope controllers. And there is the view from the upper stage camera on the Ariane 5 looking at the James Webb Space Telescope as it moves gently away from its launch vehicle.
Fantastic pictures of this telescope.
Go Webb, go Webb.
Yes, go Webb.
Ironically enough, as we marvel on this view from the upper stage camera, this will be humanity's last view of the James Webb Space Telescope as it moves to its workplace about 1 million miles away from Earth.
Yes, you're right, Rob. Impressive, fantastic pictures. Yeah.
Now we'll be hearing shortly from the Mission Operations Manager at the Space Telescope Science Institute, Carl Starr, who will be calling out the procedures that will lead to the deployment of Webb's solar array. And down in the fishbowl where there is jubilation, let's go to Raphael Chevrier of Arianespace. And before we do that, Raphael, a bit earlier than planned, but there is the solar array having been deployed. James Webb now has its array out as we stand by for confirmation that it is power positive.
Hey, Rob. J'entends pas ce qu'il me dit. Il m'a appelé ou pas? Il m'a appelé ou pas, Rob?
Non, il t'a pas appelé.
And there it is. There's your critical call. James Webb not only has legs, but it has power as it begins its journey and the commissioning activities to follow. And with that, let's go down to the floor in the fishbowl and Raphael Chevrier of Arianespace.
This is it. We have witnessed and the confirmation that Ariane 5 have safely delivered Webb into space. The upper stage is now being placed on a safe escape orbit around the Sun, but honestly, I've got to tell you that these images are absolutely incredible, and well, it may be the end of the mission for Arianespace, but it's only the beginning of the journey for Webb. It's now on its way to the Lagrange point. Congratulations to all the team involved in the flight. Really, there is no words to describe the immersion that is happening right now in the fishbowl. So all I can say is good luck, Webb, and bring us incredible data from the deep universe.
At that point, our sequence will continue.
Well, Raphael, congratulations on a perfect ride to orbit from the Ariane 5 out of Kourou here today. A view here in the Space Telescope Science Institute. Their work just beginning on a new era of scientific observations. Luce Fabregat, it was a smooth ride to orbit. Everything went by the book, almost like a simulation, without any problems. And we thank you for all of your insight throughout the course of the day.
Thanks to you, Rob, and really a great achievement. I have many faces and names now coming up to my mind, and really you can be proud of what was achieved on both sides of the Atlantic Ocean. Thanks a lot to you.
Tremendous jubilation here in the control center. You're looking at Jean-Luc Voyer, the range operations manager. Quite a Christmas present for the world's astronomers as the James Webb Space Telescope begins its life heading towards deep space. With that, we're going to go back to the floor now to Katie Haswell. Katie, we did our thing. It's up to you now.
Oh my goodness, I just can't tell you. It's such utter jubilation here on the floor in the Jupiter Control Center. Everybody's been whooping with joy. The controllers here and the mission controllers jumping up, clapping, whooping with joy, people hugging. And I have to say, my throat was caught as I saw the glimpse of sunshine on Webb solar panels as we watched it heading out into space on its journey to its working zone. It's going to take about 6 months before we start getting our deep space observations from Webb. Of course, the teams have got a huge amount to do before we get to that, and our best wishes with all those teams in Baltimore. I want to get some reaction. Right now, everybody's talking and hugging each other because they're feeling so excited, and I totally understand that. Let's start, though, by going over to the NASA administrator, Bill Nelson. Sophia.
Okay, can you go on right now?
Okay.
Administrator Bill Nelson right now looking at these jubilant scenes here in the Mission Control Center in Kourou, the European spaceport in South America. There are the teams. The mission controllers have done a fantastic job. It was an utterly flawless launch from the European spaceport here on the equator in the Amazon rainforest. Hoping to go over now to NASA Administrator Bill Nelson to get some reaction from him.
All stations, 7.5 minutes, give or take, until the sequence continues with our ADIR release part 1 and our TCS configurations.
Geostationary Orbit, filling the JW6 config.
The range operations manager has been calling out the milestones throughout the flight today. And the ESA teams responsible for so much fabulous work. Great teamwork here to get the Webb telescope into space, and Webb is now heading out on its journey, on its own, with the mission controllers, the telescope mission controllers in Baltimore, following those incredibly important first actions and first operations. Charlotte Bezko there, who's responsible for the ESA operations here at the spaceport. We're hanging in there, waiting and hoping to hear from the NASA administrator, Bill Nelson, who I have absolutely no doubt will be as jubilant as everybody here at the Guiana Space Center. Charlotte Besco, who has been working for, I think, most of her professional life in human spaceflight and now heading up the ESA operations here at the European Spaceport. Over to you, Bill Nelson.
Okay, Katie, thank you very much. This is a great day, not only for America, for our European and Canadian partners, but it's a great day for planet Earth. Thanks to the team. You all have just been incredible. And over 3 decades, you've produced this telescope that is now going to take us back in time. It's a time machine. It's going to take us back to the very beginnings of the universe. We are going to discover incredible things that we never imagined. And isn't that typical of this team, where the impossible comes possible? I can't thank you enough on behalf of a grateful United States government. I can't thank our partners in Europe and Canada enough. The French launch team, the Arianespace, the flawless perfection of the vehicle. And now we have to realize there are still innumerable things that have to work, and they have to work perfectly, 344 of them. But we know that in great reward, there is great risk. And that's what this business is all about. And that's why we dare to explore. The James Webb Space Telescope is very much a part of that exploration. It's significant that we had the delays, and it kept us all the way to today, Christmas Day, when others long ago peered up into the sky and saw stars. But it's also another millennia before that a shepherd grazing his sheep would look up at the night sky. He became a poet, and he penned the words, "The heavens declare the glory of God, the firmament shows his handiwork." That shepherd, that poet, became king. And those immortal words in Psalm 19 encapsulate the expressions that we have today. The handiwork of God as we peer back in time over 13 billion years ago, capture the light from the very beginning of the creation. My congratulations to the team. My congratulations to NASA, to our partners. Go James Webb Space Telescope. God bless you, and God bless planet Earth. Back to you, Katie.
Bill Nelson, thank you very, Bill Nelson, thank you very, very much for those incredibly moving words. Indeed, we're heading out to look at the first light of the universe, and Bill Nelson there, we have Stefan Israel with us from Arianespace. Bill Nelson there being so complimentary about the partnerships, the teamwork, and thanks as well to you guys for this fantastic launch. What a day, Stefan.
Indeed, what a Christmas gift today from the Guiana Space Center. We really want to thank NASA for its trust, the administrator, Bill Nelson. We have with us Thomas Zoburon and all his team, and our first thoughts are going to NASA. It is a journey of 20 years we have made together. We have worked as hell, I would say, to make this happen, and now it's done. I want to thank as well ESA, who is formerly our contractor for this launch. We have Joseph Ashbarer with us, we have Daniel Neuenschwander. We have worked hand by hand to make it happen. I want to thank CNES, Ariane 5 Design Authority, and our daily partner here in the Guiana Space Center. Philippe Baptiste is with us, Marianne Claire is with us. Thank you very much to CNES. For sure, I want to pay my tribute to Ariane Group, which is the prime contractor of Ariane 5, main shareholder of Arianespace, and which has delivered the launcher up to liftoff. And doing so, I pay also my tribute to Arianespace team. The Arianespace team have worked all this year to make this 14th launch of the year and this very special mission. Your dedication, your professionalism has made the success of tonight. Tonight is a great step for the space journey. It is also a great step for the friendship between the United States of America, Europe and France. So thank you very much to all of us. And now I think we can take a little bit of a rest, but we are going now to leave with Webb up to its final destination, to the Lagrangian point. Thank you very much. Thanks a lot.
Thank you very much, Stefan. And the Director General of the European Space Agency is Joseph Ashbacher. Joseph.
So Merry Christmas to everyone. And we have delivered a Christmas gift today to humanity, to people, to NASA, but also to all the people in this world. Because with this James Webb Space Telescope, we are really enabling new science, new excitement, but also really rewarding all the engineering and all the effort that has gone into it. And I'm really grateful for this success. We have delivered a mission into space. It's power positive, everything is nominal, and I'm very grateful to Arianespace and all our partners for all this work. Stefan Israel has already thanked all our partners, but let me also just very briefly recall that this was really a team effort. It was a team effort of the European team. We call it Team Europe, the European Space Agency, obviously providing the launcher with Arianespace, with CNES, with Ariane Group, with all our partners which we have to make this possible. And I really would like to spend a minute to thank all the people involved in this. Today is Christmas. Some of them are here, have been spent weeks here in French Guiana or at the sites where they have been working. It's a special moment. I know I have made sacrifices, but it's a special moment, and really thank you from my heart. But also thank you, NASA. Bill Nelson was speaking before. Thomas Zoburon is here with his team. Fantastic cooperation, and this cooperation between NASA and European team is really exemplary. And a big, big thank you, Thomas, and your people for what you have done together with us, that you have entrusted this precious spacecraft to us, which we could deliver. And I'm so happy today, I can tell you, this is a very special moment. It's very nerve-wracking. I couldn't do launches every single day. This would not be good for my life expectancy, but I can tell you this was very exciting, very nerve-wracking, but really, really very successful, and thank you from my side. And congratulations, NASA, congratulations, science community. Big science is to come, and really, really happy. Thank you from my side.
Thank you very much. So the president of the CNES, which is the French Space Agency, is Philippe Baptiste, and he joins us now. Philippe.
Thank you very much. Well, as everybody here in the room, I'm very, very happy to see that everything was fine, everything is nominal. It's great news for NASA, for ESA, for all of us. I just want to thank all the people who have been working over the last 20 years on this incredible instrument, on this telescope, but also people who have been working on the launch. I'm thinking especially on the 500 people who have been working yesterday during Christmas Eve to prepare the launch, to prepare this successful launch. And I really want to thank them very much. People from CNES, from ESA, from NASA, from Arianespace, and from all the partners who were around. I also want to give a special thank to the French Armed Force of Guyana who made this launch possible. They were monitoring everything, and without them, nothing would be possible here on this site. So thank you very much for all of them, and thanks also to all people from Guyana who are supporting this incredible European spaceport that we have here today. Thank you very much.
Thank you, Philippe. So we now have a pre-recorded message from Lisa Campbell, who is the president of the Canadian Space Agency.
I am so proud to witness the highly anticipated launch of this extraordinary mission. Je suis très heureuse et fière de m'adresser à vous aujourd'hui. It's a remarkable feat of international collaboration to think of all the scientific and engineering coordination that made today's events possible. In fact, Webb is the result of close to 25 years of planning and development with our international partners. Notre participation au télescope Webb est l'aboutissement de plus de 25 ans de planification et développement avec nos partenaires internationaux. We're playing a big role on the world stage. Canadian excellence has helped make this flagship telescope a reality. Our participation in Webb is extremely significant. It's the largest space science project in the 60-year history of our space program. Webb est effectivement le plus grand projet de sciences spatiales dans lequel nous avons été impliqués depuis le début de notre programme spatial. The successful launch of this groundbreaking telescope bolsters humanity's quest for knowledge of the cosmos and ignites interest in astronomy for a new generation. The Canadian Space Agency is proud to have contributed critical instruments to this large-scale partnership as part of a global effort to spur the next great scientific leap. We're thrilled to take part in a mission of such enormous scientific promise. Nous sommes ravis de faire partie de cette mission extraordinaire. Canadian astronomers are excited to use Webb's data and benefit from the tremendous science opportunities offered by this one-of-a-kind observatory. We congratulate the fantastic team of over 10,000 people who put all their skills, ingenuity, and effort into developing the telescope for more than 2 decades. Bon voyage, Webb! Canadians will follow your journey with great interest.
And now I'd like to hand you over to Thomas de Brucken, who is the head of science at NASA. Thomas.
Well, Katie, what an emotional day, what an emotional time. We're here, all of us who have been working together for so many weeks, months, and years, and more importantly, our teams who are taking team images behind us, who have put in front of their lives as a highest priority for so many of them to actually get this done and get it done here, working even during the holiday times. I just couldn't be more grateful to the many, whether it's Arianespace, CNES, the European Space Agency, all the amazing people around French Guiana, the forces that are here, all the good people that have been such great hosts to our teams, all of them I want to thank. You know, whenever we look at launches, they're both an ending and a beginning. They're an ending of an engineering project on the ground, and with many amazing hours and challenges that are there, but they're a beginning. They're a beginning of one of the most amazing missions that humanity has conceived, and I'm so excited to look forward to the next setup of this telescope and all the science to come. Thanks to everybody. This is what we can do when we come together, Katie, as one, humans. It's just absolutely incredible.
It's wonderful. And Dr. Z, thank you very much. Massive congratulations to you all, to everybody who's involved in today. Huge congratulations from everybody here at the Guiana Space Center, and also our very best wishes to all the teams in Baltimore who are now monitoring those early operations of the telescope as it starts to unfold. I'm going to hand you back now to Goddard, but before I do, I just want to say from all of us here at the Guiana Space Center, Merry Christmas. Over to you, Michelle.
Thank you, Katie. I can tell you that here it feels like the dawn of a new age. Historians of the future will divide our understanding of the cosmos into eras before Webb and after Webb. Webb is this milestone that marks a bold effort to look backwards in time to the mysterious origins of everything. Of course, we move at human timescales, so here's what's coming up. In the next few weeks, engineers will unfold Webb's critical sun shield to begin chilling the telescope to unimaginably cold temperatures. They'll extend the DTA, the Deployable Tower Assembly, the structure that supports the Great Golden Mirror. And then finally, they'll unfold that mirror and begin the process of fine-tuning the system for work. Through it all, we intend to bring you live coverage of all of the important events that are happening, along with expert commentary and extraordinary images from the Mission Operations Center and our own broadcast headquarters here at Webb's home, the NASA Goddard Space Flight Center. Stay with us over the next few weeks because the adventure is just getting started. Speaking for everyone on the team, it's been a great pleasure to be with you here today. I'm Michelle Fowler, and you've been watching special live coverage of the historic launch of the James Webb Space Telescope. Thank you for joining us.
Hi, it's me, Tim Dodd, the Everyday Astronaut. Good morning. Merry Christmas. Welcome to what might be one of the most memorable Christmas mornings, at least of my adult life. I can't think of a better thing to do on Christmas morning than to watch one of what might be the most historic launch ever. And this one's going to be amazing. Sorry, the background noise is really loud. Yeah, this is the big one, my friends. This is like the ultimate rocket launch. This is pretty much the most expensive and most important rocket launch, single mission, definitely in my lifetime. Maybe as expensive, it might be the most expensive single launch ever. So let's get right to our pre-launch preview. Don't forget, anytime you guys ever have any questions about upcoming rocket launches, don't forget to go to everydayastronaut.com, and you can go to our upcoming rocket launches and head on over to our pre-launch preview. So this is the James Webb Space Telescope. And my friends, this is one that's 30 years in the making. So you better believe I'm up. Didn't hardly sleep last night. Just so excited for this. And when I say didn't sleep, I mean literally, you know, that kind of thing where you're tossing and turning and thinking you're missing the test or missing work or missing some, like, I was just tossing and turning all night. Maybe slept an hour and a half, maybe 2 hours. Because this is just this one's worth staying up and stressing out over, because it is, let's get to it, and we'll you know, we'll see why this is so important. So, time of liftoff, as you can see in our countdown clock, is about T-minus 30 minutes right now. Yeah, so we are really getting in there. The mission name, this is going to be the James Webb Space Telescope, or as you might commonly see it, JWST. We've probably seen that for years and years coming. The launch provider who is going to be launching the James Webb Space Telescope is Arianespace, on behalf of ESA, basically. So the customer who's paying for this is led by NASA in collaboration with ESA, with the European Space Agency, with the Canadian Space Agency, and the Space Telescope Science Institute as well. So this is, like I said, this is a really genuinely huge mission, with international collaboration galore. The rocket for this is the Ariane 5, the ECA, the extended, the full, biggest, baddest, you know, biggest fairing, and all of the options, check off all of the options for this rocket, because this is the one. The launch location is ELA-3 at Guiana Space Center in French Guiana, which is technically a province of France, even though it's in South America. Yeah, it's which is cool because it's pretty much right on the equator, which gives it that nice little extra boost of energy and a little bit of extra velocity compared to even, say, launching from Kennedy Space Center or anywhere else in the world. Sitting pretty much right on the equator, you do get an additional bit of delta V to help push the rocket out onto its destination. So payload mass, this is 6,500 kilograms. This is a pretty big, heavy telescope, although it's still about half as light as Hubble. So it's quite the engineering marvel that it's able to be, you know, this powerful and much lighter than Hubble. So, and the crazy thing is, this is going very far away from where we are right here, right now. It's going to the Earth-Sun L2 Lagrange point. So that's actually a point between the Earth and the Sun. It's behind the Earth and the Sun relative to that. So basically, it's kind of sitting as if you were orbiting the Sun, but the Earth is constantly between you and the Sun. And you're just in this nice gravitational balance where the spacecraft will always have an equal pull between the Earth and the Sun, and then centrifugal force as well. So it basically will stay right there with very minimal station keeping, and it's a very, very cool orbit. So to my knowledge, I don't know if we've sent. Chat, please let me know. Have we even sent anything ever to an L2 Earth Moon L2? Definitely not anything this big. Definitely not, and definitely not this. Yeah, not this important either. Will they be attempting to recover this first stage? This part of the article is obviously more about rockets. You know, we tend to really be involved in the rocket launches. The reason we're watching this mission this morning is because this is the most important science mission, perhaps, of our lifetime. Some of this doesn't make as much sense, but it normally does. Like, will they be attempting to recover the first stage? No. This is where the first stage will be crashing into the Atlantic Ocean, as do all Ariane 5 rocket launches. Will they be attempting to recover the fairings? Nope, not possible with Ariane 5, so they're brand new fairings. The weather is actually looking good. All systems are green last time I heard. Pretty awesome. This will be this is pretty much topping the year off with a record-setting 138th orbital launch attempt of 2021. This is going to be this is already a historic year for rocket launches. This will be the 289th Ariane space mission and the 112th Ariane 5. So of course there are other Ariane space rockets. Ariane 5 is not the only one, although it is very prolific. So if you want to read more about this incredible science mission, and I mean incredible, this thing has over 300 single points of failure in its deployment mechanism. So assuming the launch goes well, which, you know, really extra knock on wood, cross every finger and toe you have in the world, we really hope this launch goes absolutely perfectly today. You know, the Ariane 5 is an incredibly reliable vehicle, so we really are hoping that that is the case. Even then, it has a 6-month, it goes online for 6 months. So there's about 30 days or so where there's a lot of deployments, a lot of things that could go wrong. So it'll be basically a month of just torture for the scientific community and those involved. And having seen the telescope twice in real life, you know, with my own eyes at Goddard and then out in California before it got sent to French, I think that was before it got sent to French Guiana. That was in 2019. It might not have been quite it was pretty close to the final time. Yeah, I've seen it twice, and just seeing how many people, the scale of it, and how many people are working on it, knowing that they've, you know, combed over every single little millimeter with a fine-tooth comb. This one is just, it's frankly terrifying. I mean, I would not want to be. I can imagine how nail-biting it is for mission control on this one, because it's all eggs in one basket. But, you know, the consequences of this launch are going to be incredible. Like, you know, this thing will be able to look deeper into our universe than anything has ever looked before because of physics, really. In order to get, you know, our own atmosphere will block a lot of valuable data from optics and from collectors. But you know, you have things like the Hubble Space Telescope and other space asset telescopes that get outside of our atmosphere that allow the sensors to collect more light, collect you know, infrared light and things outside of the visible spectrum, things that sometimes our atmosphere tends to absorb. But this is about the minimum of what scientists believe will help us capture basically the beginning of the universe. And that's mostly because this will capture in the infrared spectrum. So because of light shift and because of the fact that the universe is moving away from you, a lot of it has shifted into the infrared. So we're literally being able to like look back in time basically with this telescope. If that doesn't get you excited, I don't know what will. And its resolution and what it's going to be able to detect is going to be off the charts. This is the one, guys. So yeah. So here's what I'm going to do. I'm going to encourage all of you, if you want to hear. First off, if you want to read more about this, please visit our website, everydayastronaut.com. Click on upcoming launches. You'll read plenty about the rocket that's carrying this and the payload and the scientific missions. This was written by Claire. Thank you so much, Claire, for writing this article. But I'm actually going to do something. I'm going to encourage you guys, I'm just going to be talking. I'm going to be answering your questions. I'm going to be yabbing a whole bunch, right? It's Christmas morning. Got an exciting mission. I'm going to be yabbing and watching a rocket launch with you guys. That's what I'm here for. I'm here to answer questions specifically mostly about the rocket. I'm not a planetary scientist. I'm not none of that stuff. I'm a spaceflight enthusiast. So I'm here to answer questions about your rocket. If you want to learn more about the Hubble, or about, see, good thing I'm not even, about James Webb, please watch the official NASA feed. It's incredibly well done. It's hosted by Dr. Michelle Thaler, who is an absolute rock star of science. So listen to them. If you want someone to yab that knows what they're talking about with these specific science instruments, please watch the NASA feed, the official NASA live stream. That is, to me, that's, you know, if I wasn't doing this, wanting to watch this rocket launch and hang out with you guys and answer your questions, that's where I would be. So just wanted to encourage you. You have the option, of course. It's YouTube. Choose whatever you want. But we've got a lot of questions from you guys already. And including some fun things like this, like John Bauer is celebrating 12 months of membership on the channel. That is awesome. Thank you so much. That really means a lot for those of you that do support what I do here. It really, really means a lot. I know that I talked about this on Twitter, but you might not believe this, but we're actually gonna have 3 videos coming out in basically the next week and a half. Basically in the next week, we're gonna have 3 videos dropping. Yeah, you didn't even think that was possible for me, did you? We've been working really hard on some other videos in the background, trying to get them out as soon as possible. We, of course, have our Astro Awards. So assuming this launch goes well, believe it or not, assuming the launch goes well, this isn't going to make it into the actual Astro Awards. It'll make it into the honorable mentions as a successful launch. So kind of a congratulations to Arianespace. But James Webb won't get its Astro Award until it starts collecting mission, and its official mission starts collecting data, and its official mission starts. That would be a success. That will be so 2022 would be the year that we'd maybe be giving it an Astro Award to the success of James Webb, and it would be high up on the list. I'm having a hard time even imagining what else would be that high on a list. I think this is an absolute shoo-in for #1 next year, assuming this launch goes well today. So we're going to be releasing the 2021 Astro Awards at the beginning of the year, likely the 1st or 2nd. We also are releasing a really fun video that we did last year with you guys. At the beginning of last year, I put out a Twitter poll trying to guess what was going to happen in 2021 throughout the year. We were horrible at guessing. So we're going to go through the results of what everyone voted. It's a super fun, short little video, and that's going to encourage us to be able to, on January 1st of 2022, I will be doing a similar poll, hopefully a little bit better on my end, because I didn't do the best job of predicting what to even be thinking about. You know, it was kind of a hastily put together set of polls. So this one will be a lot more accurate, a lot more fun. So I hope that you guys join in that one and see the results and see how you did if you took a part in that poll too on Twitter at the beginning of this year. That's going to be really fun, and just a kind of to what's that called? I can't even think because I haven't slept. A nice little pairing with the Astro Awards. So yeah. Oh, and then we also have a 27-ish minute video about why rocket engines don't melt. We're talking about all of the deep dives on that kind of stuff of how you keep a rocket engine from melting or vaporizing or sublimating. How do you keep them cool? There's a lot of cool techniques that rocket engineers get to employ in order to keep rocket engines at operational temperatures. And we're going to talk to you guys about that. And it's a really fun video, lots of good animations, kind of back to the classic everyday astronaut, like how does this work type of thing. So hopefully you guys enjoy that. Okay, so this is from Musical Wolves. How are you doing, Musical Wolves? So good to always hear from you. Mary Wolfmas, will the rocket be Rudolph the Red Engine after ignition? So no, the Vulcane doesn't really burn that glowing red hot. It is regeneratively cooled all the way down the nozzle. I'm trying to remember what the second stage, I'm pretty sure it's also regeneratively cooled and does not have like a radiatively cooled nozzle extension that would be indicative of a bright red glowing rocket engine. I don't recall, but yeah, I'm pretty sure that there will be no glowing, although the SRBs, just the flame coming off of the 2 massive boosters on the side of this vehicle will be bright. I mean, those things are stinking bright, and they might not be red, they might be more yellowish, orangish, but yeah, we'll definitely see, when this thing lights, it gets off the pad in a hurry with those massive solid rocket boosters. This is similar to like a space shuttle without the orbiter. That's what the Ariane 5 kind of reminds me of. It's 2 giant solid rocket boosters, a single sustainer engine instead of the RS-25 main engines on the space shuttle. Just one a lot less powerful version, but wow, there is some wildlife going crazy right now. Yeah. All right, let's keep going here. This is from Michael Maxey. Remember, guys, too, if you want your comments up on screen, just have a good question, and maybe our mods will catch it. And thank you to our mods for hanging out with us on Christmas morning or Christmas afternoon. This is the most stressful launch for the astronomical community and spaceflight community, and I think science community at a whole. Yeah, this is just crazy. So, yeah, let's see here. We had a membership from Tom Kennedy. Thank you, members. You will get early access to some things. Just like you do if you're a Patreon supporter. So thank you to all of the people that help me do what I do and hopefully do more and more of it. From Caesar, loving the jumper. Yes, my mom and dad gave this to me last year. It's about as ugly as it gets, and I love it. It's Santa, the astronaut. Yeah, it's good. It's appropriate for Christmas morning. Let's see. Tim says for the non bullshizzle delivery, NASA guys are driving me nuts with their cheesy hyper-inflection fakeness. Well, I mean, that is the traditional broadcasting way. I think that's that's the way that it's just kind of always been done in those realms. I can tell you this, though, having spoken personally and hung out with Dr. Michelle Thaler, who's the main host, for a full day back in 2016, she is incredible. Or 2017, I think. I don't remember. Around there. She is infectious, and her tone is genuine. What I don't like about that kind of presentation is they make her asking questions that she knows the answers to. I wish that she would say, that they would script it so it's like, a common question is, can you talk about that? Instead she'll be like, now why do planets, it's like, you know this, like don't have your brilliant host who's one of the smartest humans in the world, asking questions like that. Like that's one of the things that irks me about that way of doing things. Because she is so brilliant. I mean, yeah, just look at her laundry list of missions and things she's taken a part of. She is unbelievable. So, yeah. From Nick Perry, happy Boxing Day from Ettore. I don't even know what that is. Thank you very much. Dr. Bright, thank you. Hey Tim, I've been a fan of your channel for a while and always tune in here for big launches I'm hyped for. Have a happy holiday. Thank you so much. It's unusually warm here in Iowa. Yesterday it was 52 degrees Fahrenheit, so like, I don't know, what is that, like 12 or something? 12-ish, 13-ish Celsius. It was unusually warm. Normally it's below zero or it's freezing. It's normally like say 20 degrees Fahrenheit or like -4 or 5 Celsius. So yeah, very happy to be having a nice, just beautiful Christmas with the family and beautiful holiday season. Okay, so this is a good question. Why Ariane Space? Is it really the best option? What is better about Ariane 5 than others? This is a really good question, Extreme Julius. So there's a few things here. Oh.
Live audience from our broadcast booth high atop the Jupiter Control Center here in Kourou. Joining me today for this historic launch, my colleague Luce Fabregat, head of infrastructure and value chain for the European Space Agency. Luce, good morning. Great to be with you. Great to be with you today.
I'm not loving the
Very pleased to be here with you and all of you watching us for this.
This is launched by the French, the Ariane Space, so it needs to be in French and English, but I don't know why they're broadcasting both.
15 minutes, 32 seconds and counting. Out on the launch pad, everything is in great shape. Don't let those clouds fool you. We are go for launch. The latest weather briefing just completed indicated that all weather parameters are green. We have a green board here in the control center, and everything has gone extremely smoothly in the countdown. About 9 minutes ago, a major milestone passed as the James Webb Space Telescope.
All right, this is a little too confusing for my ears. I can't handle this. I'll try and listen in and let you guys know. I'll also try and do some audio stuff. And here we go. Actually, I can just do this. I can go desktop audio. and then mixes down to mono, and we don't have to, we can hopefully hear. Let me know if this works for you guys.
Earlier, telescope controllers reported good environmental readings from sensors inside the fairing, encapsulating the telescope atop the upper stage of the Ariane 5 rocket.
Okay.
And Luce, as we enter the most critical phase of the countdown, can you outline some of the upcoming critical activities as we head into the phase called Synchronized Sequence?
Yes, Rob. We are now reaching the end of this 11-hour sequence that we call the chronology, and that started yesterday evening. All systems here have been prepared for the final launch operations. And at the time being, it's rather quiet now inside the launch table and also inside the launcher. We were told a few minutes ago by the Launch Control Center here that the launcher fluids and electric systems are ready for the final automated sequence. They are on hold now, waiting for the last weather report at -10 minutes. After this weather report, 3 minutes later, we will have the beginning of this famous synchronized sequence when all systems will be made ready for the liftoff. This sequence will first be run by the ground calculator, and then the onboard computer will take the lead step by step, and the launch vehicle will be made autonomous from the ground system.
Okay, I'm gonna go back to answering Extreme Julius. I see so many good questions. I want to get to these. But it looks like everything's good to go. We're, again, T-minus 11 minutes from history. But Extreme Julius had a really good question. Why Ariane Space? Is it really the best option? What is better about Ariane 5 than others? Well, number one, it's the only rocket with a large enough payload fairing to actually really be able to fit all of this in properly. It is huge. It's a 5.4 meter wide fairing. I think it's only about 4.8 or 4.6 meters internally, but that is like stuffing it to the brim. And that's exactly what James Webb Space Telescope does. It stuffs that thing to the brim. So, yeah, it's so there's that. That's important. But also, what's cool about this is one of the things that ESA's basically donating the launch. So ESA's paying for the launch. That's part of their collaboration with the James Webb Space Telescope. Is they're paying for the launch. It's a not insignificant amount of money, likely, 500 million or something. I'm not sure the exact number. Compared to the $10 billion telescope inside, it's obviously not the biggest piece of the pie today, but it is a very generous contribution, is to be able to provide the launch vehicle. So, yeah, that's part of the international collaboration. People ask things like, why not Falcon Heavy? Falcon Heavy would not have the fairing size, the width, nor the height with its standard. It also can't be vertically integrated, meaning you can't just, the James Webb Space Telescope had to be dropped down on top of the payload adapter while the fairings were off, and then they could encapsulate it. The Falcon Heavy and Falcon 9 get encapsulated horizontally while they're on their side, and they roll out to the launch pad and rise to vertical. This needed to be vertically integrated. So that's another thing that Falcon Heavy can't do. Also, when this mission was conceived and paid for and planned out, Falcon Heavy was barely a paper rocket at that point, It was basically a PowerPoint and a pretty animation. So it was far from an option for this particular ride. Yeah. All right, so let's keep going here. I know we have a lot of people. Don't worry, we'll get to the check. We'll get to the check, my friends. Yeah, I hope that we get back to the shots of the rocket here. I will listen in a little bit myself to make sure I'm not missing anything. Oh. Actually, weather.
A couple of days, but right now everybody is very focused on the next steps. The start of the synchronized sequence at 7 minutes before liftoff. Last operations that Luz described earlier before Webb and the Ariane 5 are going to lift off and soar into the sky.
Thanks, Raphael. We'll be back with you and Luce here shortly. We now have confirmation from Baltimore that James Webb is on internal power. Amidst all of this activity, we cannot forget that it is Christmas Day. 53 years ago, the astronauts of Apollo 8 completed their 10th and final orbit of the moon after reading from the book of Genesis on Christmas Eve to billions of people watching with rapt attention back on our planet. The astronauts then headed for home following their spacecraft's trans-Earth injection burn. Today, more than a half-century later, we're just minutes away from another genesis, the genesis of new era of discovery. The launch of the James Webb Space Telescope is at hand.
Very cool. Okay, so let's see. Thank you so much to Physics Gamer or Games for this is that Lagrange point 2 Earth Sun Lagrange point 2, the ESA Gaia probe, and the joint Russian-German high-energy astrophysics observatory, Spectre RG. So there are two other vehicles out at this same similar Lagrange point. It's not like they're going to physically run into each other. There's still in this kind of little bit of a halo orbit. There's a lot of space out there. All right, let's see. Oh, we're getting into the final sequence here.
Top, à 0-7 minutes.
And with that, we've entered the period of synchronized sequence. You heard Luce Fabregat just a moment or two ago explain some of the critical activities. The first one coming up just a few seconds from now, which will be the topping off of the main stage.
Cool. So everything's still going smoothly. We have about 6 more minutes. Okay, this is a really good question from Rexalot. Now, this vehicle, James Webb Space Telescope, only has a 10-year operating mission. After 10 years, it'll basically run out of the maneuvering thruster and the propellant inside the maneuvering thrusters that kind of keep station keeping. You have to keep using those occasionally. There are reaction wheels on this vehicle to help point it and steer it and guide it and keep it steady. There's 6 of them. But the problem is they get what's called saturated. So eventually they spin up so much that they need to be desaturated. And during that time, you do have to use thrusters. You also have to fine-tune your orbits occasionally just to be perfect using some of your propellant. So there's a little tiny bit of propellant on this vehicle, but that little tiny bit of propellant can last about 10 years if it goes well. The question being, if this all works great, in 10 years, could we send something to service it? Sending humans that far, there currently are no real legitimate capabilities for that, so that would kind of be out of the question. But things like Northrop Grumman's MEV, the Mission Extension Vehicle, could maybe be an option, and that can actually go up and basically dock with the engine bell of a rocket engine or a spacecraft's engine. Basically hold on to the engine and then be able to like refuel it and top it off and do things servicing wise to it. I don't know if that's a possibility, but I think there's some talks of there already being some feasibility options on the table. Depending on how this all goes, if it's all going great, then yeah, this might be such a valuable asset. We'd want to try to extend its mission beyond 10 years, and we do, as of 2020, have some autonomous options there. Robotic options that can actually go and service vehicles and extend their mission life. And this would be one that I would absolutely love to see be extended, because I think 10 years, if this does what it's promised to do, will be worthy of a massive extension. Wow, thank you so much to everyone with the generous super chats this morning. I really appreciate it. I'll keep trying to answer questions again, non-super chat questions and super chat questions. I might not get to them all before the launch, and then as soon as this thing deploys, I'm gonna go enjoy family time. I'm gonna enjoy Christmas morning with my family. So I apologize if I'm unable to get to you guys. But this is a good question from Rigel. What is the megapixel of James Webb Space Telescope? I believe it's the total resolution ends up being about 16 megapixels. Now that's not just total, that is there's actually 4 sensors kind of all blocked together. They split some of the sensors. There's a lot of extra instruments besides just like the imager. So that's, the end result can be about 16 megapixels, but don't forget you can do panoramas and keep extending that to be hundreds of megapixels, just like you can stitch together photos with your phones or your cameras. You can do that similar thing with telescopes and assets like this too. So, all right. Let's see what's in the boosters. The boosters are solid rocket boosters, so they're quite literally just like almost a rubber propellant. Has its oxidizer and the fuel built in. Very similar again to the space shuttle's solid boosters. In the center, though, the core of the vehicle, the center part, is all liquid hydrogen and liquid oxygen. Both stages, the first stage and the second stage, are liquid hydrogen, which are very efficient, has a lot of potential for a high efficiency, but they're also very sparse and undense, so they have huge tanks. So this vehicle always looks bigger. It's a lot lighter than some other rockets that would be similar to this. So, Let's see. Yeah, hopefully we answered all the questions, you know, about why the Ariane 5. Let's see. This is from Juan Fran. Do you think this would be the last important launch from Arianespace, taking into account Starship, Merry Christmas, from Spain? I mean, I'm sure Arianespace, you know, they're working on the Ariane 5 or Ariane 6. I do, you know, I don't think this is going to be their last important mission. I think they have quite the life ahead of them. They've proven to be quite reliable, too, so. All right, let me keep talking here a little bit here. We're coming up on T-minus 2 minutes. Holy cow. 30 years in the making, my friends. 30 years coming up to this point to launch this vehicle, so. Wow. I want to get to that question right now from the Legacy. There's a lot of double time and double time and a half on payroll at NASA today. Surprised they didn't wait another window. Well, they've waited 30 years. This vehicle needs to get off the ground ASAP. It's probably cheaper to get it in the air than to... Oh, they're all going outside to see the launch? It's getting real. Oh, I would want to have been out there the whole time. Now they're like T-minus 1.5 minutes. It's like, run! Run! Get outside. You're about to see the craziest thing. Oh, man. Okay. Coming up on... yeah, so I don't know a ton about this. There is the possibility if the upper stage burns a little too long or overperforms, which is less likely than it underperforming. It is hard for the James Webb Space Telescope to slow itself down because of the orientation of the thrusters. So, T-minus 1 minute. All right, I've got a very important thing to go here. I have to perform the pointy end up, flamey end down. So, based on this image, it's actually a really good perspective image. I can confirm the pointy end is up, the flamey end is down of the James Webb Space Telescope, my friends. I've been waiting about 6 or 7 years since I first learned about this to see this thing fly. Here it is, Christmas morning, the ultimate package. Now, I want to tell you what to expect. The center engine is going to light up and run right at T0, and then it sits there on the pad for a long time, like 7 seconds before it takes off. So don't panic if it's just sitting there running. You're like, what is going on? That is okay. I'm going to listen in here. Fingers crossed, everybody. Merry Christmas.
Attention pour les deux
Go
comptes
James
finales.
Webb.
10, 9, 8, 7, 6, 5, 4, 3, 2, unité, top.
I said it'll sit here for a second.
And we have engine start. And liftoff.
Décollage.
Decollage, liftoff from a tropical rainforest to the edge of time itself. James Webb begins a voyage back to the birth of the universe. Punching a hole through the clouds, 20 seconds into the flight. Good pitch program reported.
Trajectoire est nominale.
Vehicle performance is nominal. The Ariane 5 rocket continues to fly uphill in nominal fashion. The rumble of the powerful Ariane 5 now being felt here in the control center. 3D animation.
Shoot, they don't have better... I would have thought they would have brought out all the other assets here. So this is just a... Okay, but we can look at the actual velocity down there. Will be real time. But the animation is not real time, so that's pre-programmed animation, I believe.
The trajectory reported to be nominal by Jean-Luc Voyer, the range operations manager. You can see at the bottom of your screen, the yellow line is the trajectory plot, perfectly overlaid over the green line, which was the pre-launch trajectory. 1 minute, 41 seconds into the flight, about 40 seconds away from shutdown of the solid rocket boosters. Coming up on the 2-minute mark into the flight.
When it detects the threshold on acceleration, not the deceleration, but less acceleration for
Tous les paramètres à bord sont normaux.
Everything is okay. Everything is normal.
2 minutes, 15 seconds into the flight.
Here comes booster separation.
When the computer detects this threshold, it will separate.
Séparation des EAP.
Done.
We have confirmation of solid rocket booster separation from Jean-Luc Voyer. This coming at an altitude of 44 miles. The Ariane 5 and James Webb traveling almost 5,000 miles an hour.
Next will be fairing separation.
We have about 1 minute, 5 seconds to go before fairing jettison. That'll be the next critical milestone.
The fairing is there to avoid the satellite being exposed to high temperatures and also high airflows. And as soon as the launcher leaves the atmosphere, as is now the case, the satellite does not need anymore to be protected, and Webb does not need anymore to be protected. So each kilogram being very important for the performance of the launch, we are going to eject this no more useful fairing.
And let's go down to the floor in the Jupiter Control Center to Raphael Chevrier of Arianespace. Raphael, so far so good.
Hi, Rob. So far, so good. Everything is nominal, as we say, when attitude and trajectory of the Ariane 5 is going perfectly well. As you can see also on the yellow line on the screen, we had the confirmation of the separation of the two solid boosters and now of the fairing, meaning that we have crossed the limits of the atmosphere. So everything is going super good. And the DDO just said that all parameters are going perfectly smoothly. So let's continue the mission.
And Raphael, this is a view from the upper stage camera called the Vicky Cam, looking back at the James Webb Space Telescope. This is on about a 20-second delay or so because of the way the imagery is processed here in the control room. There's your telescope ready to unfurl its wings basically and begin its journey to the Lagrange point, the L2 point, about 1 million miles away from Earth.
Wow.
La trajectoire est nominale.
Trajectory is nominal. The report from Jean-Luc Voyer. The liftoff time confirmed here in the Mission Control Center at 12:20 Greenwich Mean Time, 9:20 a.m. Peru time, 7:20 a.m. Eastern Time. The Ariane 5 and James Webb, 181 kilometers in altitude, 450 kilometers downrange from the launch site here in Kourou.
Flight control is very smooth.
5 minutes, 12 seconds into the flight. We have about 3.5 minutes to go in main stage or first stage performance. And again, you can see at the bottom of your screen the yellow plot line overlaid over the green line, meaning we are right on course, right down the pike, and a perfect trajectory so far for the Ariane 5 rocket.
So basically, the core stage here pretty much puts the vehicle into orbit. You know, it's again similar to the space shuttle, where it's a sustainer engine, so it's running from sea level all the way to pretty much orbit. And then it'll separate, and then the upper stage has to do the final insertion and the injection. Wow. Sorry, I'm just like speechless that it's going well. This is fantastic.
Map in the middle of the ocean, and the two last stations in Africa, Libreville and Malindi, one on the east coast, the other one on the west coast. And the one on the west coast, Malindi, you can see that the satellite will be, the telescope will be separated more or less over this Malindi station. And this Malindi station will also acquire the telemetry data from the telescope. You can see both are green, Galileo and Dantal on this animation. It means they are expected to receive the data, and it was confirmed right now by the launch operations manager.
Acquisition de télémesure par la station du Natal au Brésil.
And just confirming now that telemetry is being processed through the Brazilian tracking station. The telescope is also processing telemetry through the tracking and data relay satellite system. As it moves further and further out into deep space, all of the telescope's telemetry and its imagery ultimately will be processed through the Deep Space Network in Goldstone, California. We passed the 7-minute mark into the flight. A perfect ride so far on the Ariane 5. We have about 1.5 minutes to go in the first stage performance. Once the main stage engine is commanded to cut off, it will be jettisoned, and just a few seconds after that, the upper stage engine will ignite, and it will be the workhorse for a 16-minute burn that will put James Webb into its preliminary orbit.
Yeah, so the upper stage will burn for 16 minutes. That is
about
crazy.
11 minutes from now. Telescope controllers at the Space Telescope Science Institute will be sending commands to prepare James Webb for the initial series of commissioning activities that will lead to the deployment of its solar array and the initiation of generation of electrical power for the telescope. About 30 seconds away from main engine cutoff.
Yeah, like we said, basically the
trajectoire est normale.
Trajectory is still normal. I did say normal. The first stage basically puts it into orbit. You know, with a light enough payload, it absolutely would be capable of that. Similar to how, do you remember earlier this year, China had a rocket where it's similar to this, has a sustainer core like this, and they actually let it get into orbit, and then they didn't intentionally run it short of orbit like this will. There we go.
Opération EPC.
And we have main stage shutdown and separation confirmed here in the Mission Control Center, and the ignition of that upper stage. And Raphael Chevrier down in the fishbowl. So far, so good.
Yes, Rob, we have the confirmation of the separation of the main stage.
The second stage engine is about 440 seconds of specific impulse, if I recall.
Very important moment for us because it's always a challenge to switch on a cryogenic engine in space condition, and we are now at 220 kilometers of altitude. Speed is a bit more than 7 kilometers per second. As we enter now the second stage of the second phase of the flight, the upper stage is going to power for about 16 minutes to place Webb on its transfer orbit, and right now everything is again nominal, as the DDO just said.
And a short time from now, the so-called Sawtooth Maneuver will get underway. Again, like rocking a baby in a cradle, this will be a maneuver to keep Webb's optics protected from overheating, Luce.
Exactly, Rob, like a baby in a cradle. You can see here Webb attached on top of Ariane 5 upper stage with a very specific configuration. Of course, it will be different during its lifetime, but for the time being, its sun shield is folded and not yet fully protecting the observatory. A number of exhaustive studies have been performed by the mission teams in Europe, in the US, on the thermal conditioning inside the telescope and the way the rays of the sun would propagate and interact with sensitive equipment.
I did want to point out and rest assured that, yes, the rocket and the vehicle is actually going down in altitude a little bit, and that's okay. What they do is they loft up before stage separation. They get the vehicle in a lofted trajectory, and then you actually do want to be as close, as low as you can when you're doing an injection burn like this. The higher you are, you're actually going slightly slower. So the O-berth effect is what that's called, is where the closer you are to the planet, the planetary body where you're doing your injection burn, the faster you're actually traveling at the same relative, everything else relative. You're faster if you're closer. So they actually want to be kind of like getting as close as they can, and this is a very low power second stage. If I recall, it's only like 70 kilonewtons or something. It's a very low power second stage. Actually, it's 67 kilonewtons. So it, you know, it just will sit there and burn for a long time, and it's okay that the altitude goes down. What we're worried about here is the thing that at the bottom left says vitesse or something like that, and that's velocity. It's currently at 7.56 kilometers per second. I'm not exactly sure what the end number is. It's probably going to be around 10.5 or 11. You know, a moon mission's about 11, if I recall correctly, or 10.5. So, or 11, I think. So this is probably around 11.5. It's beyond the moon. So we're just worried about that number really so much, and not necessarily the altitude. So don't worry if the altitude's going down. I just wanted to give you a little bit of, yeah.
We'll get
I'm still
the call
hearing
that electricity is flowing
radio,
through
so
the array. That call will come from the mission operations manager, Carl Starr, who is at the space.
If you guys taking a breath yet, I want to remind you to breathe. If you're anything like me, sincerely, this is a big deal. This is, you know, one of the most expensive single missions ever. I think it is the most expensive single mission payload. Like one payload being worth so much money, $10 billion. And this is yeah, this is a big deal. The fact that this is going smoothly is everything. So yeah, so stage separation, if I recall, is at T plus 27 minutes. I will be with you guys until just after that, and then I'm going to wrap up and go spend Christmas with my family. So everything's going perfectly smoothly, though, so far.
This particular mechanism helps with heater control of the fine steering mirror, preventing water ice condensation, later to be used to position each of the mirror's segments. All 6 reaction wheels and the wheel drive electronics will be powered on for Webb, and that will be the precursor to the attitude control system using those reaction wheels to maintain the proper orientation with the sun, as opposed to using onboard thrusters. Of course, fuel in those thrusters, very valuable. It's a limited commodity for the lifetime of James Webb's observations of the universe. We're 13 minutes, 55 seconds into the flight. Jean-Luc Voyer, the range operations manager, continues to report a nominal performance for James Webb. And again, Luce Fabregat from the European Space Agency, how is this trajectory being carefully and methodically adjusted to provide the correct parameters in the final stages of ascent?
Yes, Rob, as you can see on this plot, the altitude is slightly going down. It's perfectly normal. The launch vehicle is really on the line where it should be. This decrease of its altitude, slight decrease of its altitude, will allow the launcher to benefit, and the upper stage to benefit of the gravity effect, and to increase its velocity until it reaches a thermal threshold. It's about to reach it, or even already reached it now, and it will go up. And now it will go up and up to the separation of the Webb telescope. It will separate the Webb telescope.
On that, people were asking in our Discord channel, why is the trajectory going down and then back up? And she kind of explained it there again. Because of the O-berth effect, you want to get as close as you can, but even at 180, 185 kilometers in altitude, or about just over 100, 110, at about 110 miles in altitude, there's still actually a decent amount of atmosphere. I mean, there's a non-negligible, like there is some atmosphere. The atmosphere doesn't just stop once you get to 100 kilometers. We define space as 100 kilometers, but it's not like at 100 kilometers all of a sudden the atmosphere just turns off. It slowly tapers away, just like when you climb a mountain. You can feel the air getting thinner when you're up on an airplane. At 10 kilometers, it's even thinner yet. It just continues until it's thinner and thinner and thinner until it eventually is basically more or less gone, right? And so what they're doing is, there's a trade-off here where you want to, in your orbit, when you're doing your injection, again, you want to be as close to the planetary body as possible doing your injection burn, because it's basically, notice it, look at it, literally that trajectory line down there looks like a downward thing like this, It literally was going downhill. During that period where it's going down, it was gaining 9.8 meters per second of acceleration from Earth. Earth was literally pulling it back down. And they're kind of using Earth in a sense to slingshot it out to its destination. But now they were talking about on air that they can't exceed a certain thermal threshold, because again, they were going, 8 kilometers per second with a little bit of atmosphere. It can start to actually warm up the spacecraft. So they had to mitigate that. So that's why it's now beginning to go back up. And also because of orbital, how orbital mechanics work, they're speeding up so much now the orbit is starting to increase. And that's going to end up just raising their orbit. So opposite of them, so on the other side of Earth right now, they're basically, you can imagine like a hula hoop growing away from this vehicle. And they're starting to climb that hula hoop now. So you'll now see the altitude go up pretty drastically just because their velocity is getting so high. They are beginning to just leave planet Earth now with this vehicle. So sorry if that was a little bit long-winded, but...
Rob, the velocity you just mentioned at separation of the telescope is very important. It will be slightly below, okay, I give it in a kilometer per second, but it will be slightly below 10 kilometers per second, because it's important that the satellite, the telescope, is not inserted on an escape orbit. It will be placed on a terrestrial orbit so that there will be time for the layup, for the early phase operations on and the commissioning of the telescope. And that will be, in fact, the upper stage that will leave this orbit and goes toward an escape liberation orbit.
And of course, even though we're still in powered flight, the trajectory, the acceleration, the speed at which James Webb is going towards its preliminary orbit, all modeled in advance and carefully choreographed to maintain as quiescent an atmosphere and environment around the telescope for its ultimate separation from the upper stage of the Ariane 5 rocket, which is about 6.5 minutes from now.
Yes, so 6.5 more minutes before... Yeah.
18.5 minutes into the flight. It's very quiet now here in the control center, here in Kourou. NASA officials, European Space Agency officials, Arianespace officials, all watching telemetry very carefully.
So I wanted to remind you guys that they'll be separating James Webb from the upper stage of the rocket at about 27 minutes. And then it's a 2-week process to basically really even begin to unfurl all of its stuff. And then even another 2 weeks to really get it like fully online to the point where like everything's checked out. And then 6 months total like to calibrate it and really get it into science mode. Because that's what's nuts is it has all these mirrors. You see those hexagon mirrors. They can fine tune each and every one of those to like the most unbelievably accurate alignment with the secondary instrument and the secondary mirror. I think I heard that the motors that spin and adjust those mirrors can move at the rate of a piece of grass growing. That's how accurate we're talking about. Think about the grass in your lawn growing. That's how slow the motors that steer these mirrors. That's why this is going to be so next level. It can fine tune its focus to just the absolute most absurd degree. So we're really expecting really big things out of this telescope. And so far everything is looking fantastic. Right down the middle. And that trajectory is just looking fantastic.
Countdown was as flawless as you can imagine. The weather was perfect all the way through the early morning hours, through the fueling process of the vehicle. The weather's been a bit dicey here in Kourou over the past few days, but everything fell together on this Christmas day to send a new present to the world's astronomer. 20 minutes, 40 seconds into the flight.
Trajectoire normale. Tous les paramètres à bord sont normaux.
All parameters nominal as reported by Jean-Luc Voyer, the range operations manager. 4 minutes of powered flight remaining.
What other questions do you guys have? Yeah, I mean, I love how he said, like, we're delivering a gift for the astronomy community. Again, the implications of this telescope are I mean, it'll make Hubble. Remember when Hubble, you know, some of the most famous images of Hubble is when it decided that they aimed it at a completely blank patch of sky, or a relatively blank patch of sky, where there really wasn't anything of any interest, and just sat there and exposed that darkness for, I think it was like 10 days. And when they did that, we realized that isn't empty. And they exposed literally like thousands of galaxies, and we were like, oh my word, you know, just really was eye-opening of this, like kind of this moment of, wow, this is, everything is so much, you know, grander and bigger, and just provided this new perspective that us humans have never had before. James Webb might take that times another level, because now we're able to go so much further back in time, basically. You know, theoretically as close as physically possible to the first things that were emitting light, or really close, only about 100 million years after the Big Bang. It should be able to detect some of those photons still, which is absolutely wild. So yeah, this is a really, really big deal, and I can't even begin to imagine what types of things and what types of discoveries this telescope could have. I mean, you don't know. The unknowns are unknown. You know, the cool thing is, you know, how this works is you can theorize, you can have hypotheses, and then you can start to collect data and see how that lends to your theory. And eventually, you know, if you keep trying to prove your stuff wrong and everything is saying, hey, no, actually we collected the data, it's completely correct, you can start to be like, okay, well, that's now a scientific consensus. And that's what this telescope will be able to do, is really check off, I think, a lot more of those potential unknowns, a lot of those things that we just don't really understand about our universe. This will really be able to sit there and go, you know what, look it, that was exactly right. Or what can be even more exciting is, hey, we didn't quite have that right. Now, why is this like this? How did this happen? And that's, to me, just as exciting as anything. So, yeah, here we go. We're coming up on
1 minute of powered flight remaining.
Yeah, 1 minute of powered flight left. Yeah, this is a good point, too. Jesper says, where did that go? Jesper said, I hope they redo the deep field image with James Webb Space Telescope so we can compare them. I would love, too, if we use both of them, like, to be able to observe something together in the night sky. I think that'd be amazing. You know, some kind of, you know, think about the stereo imaging you'd have of two powerful telescopes like this looking at the same object, you know, in our own solar system. Even that's what's so cool about this whole thing is, you know, we can use this for the furthest reaches of space, but of course it's going to be a powerful observatory inside of our own solar system even. You just, the options are endless, you know. Okay, here we go, waiting for stage shutdown.
And we're standing by for upper stage shutdown and the cutoff of the upper stage engine.
Extinction ESC. Tous les paramètres à bord sont normaux.
The extinction of the shut-off of the cutoff of the engine was confirmed exactly as expected.
Yes.
With the exactly expected altitude and speed and velocity. So now we have entered the coasting phase, the ballistic phase that will last for a little more than 2 minutes.
Good job, Ari, on space. Wow, I cannot imagine the stress. I cannot imagine the stress of that one, being like, we have the most important payload in human history to date. This has to go perfectly. I mean, I just can't imagine the stress that they're going through. So huge congrats. So next thing we're waiting on is the separation of the telescope and the second stage. There's a payload adapter that'll basically let go of it and push it away. And that's what we're waiting on here at about T plus 27 minutes. This is a good question here from Neil Holmes. What's one thing I'd be most excited to see this detect? Anything I've really thought about? For sure, I'm excited for it to look at exoplanets. I want this thing to be pointing at some of these, you know, planets that we know about that are orbiting distant stars, right? You know, other solar systems, because this will have resolution and be able to detect things and make discoveries about other solar systems that we just simply cannot do right now, especially in the infrared spectrum. A lot of planets, absorb a lot of the visible light spectrum, and seeing it in the infrared, you can gain a lot more data, collect a lot more knowledge when looking at an exoplanet with a telescope like this. So it's going to be really, really cool. That's something that I'm looking most forward to. Here we go.
Separation.
That's just the animation. Let's wait for the call out.
Séparation Webb Space Telescope. Go Webb!
Holy crap.
We do have confirmation of observatory separation. The James Webb Space Telescope, amidst applause here in the Mission Control Center, now taking its first steps in pursuit of cosmological discovery.
Ariane Space. Everyone, not only applause for James Webb so far, but huge props to Ariane Space. Again, that would be the most terrifying launch. I can't imagine.
Yes. Controllers.
There's that downlink.
And there is the view from the upper stage camera on the Ariane 5 looking at the James Webb Space Telescope as it moves gently away from its launch vehicle.
That's so cool.
Fantastic pictures of this telescope.
Go Webb, go Webb.
Yes, go Webb.
Ironically enough, as we marvel on this view from the upper stage camera, this will be humanity's last view of the James Webb Space Telescope as it moves to its workplace about 1 million miles away from Earth.
Yes, you're right, Rob. Impressive, fantastic pictures. Yeah.
Now we'll be hearing shortly from the mission operations manager at the Space Telescope Science Institute, Carl Starr, who will be calling out the procedures that will lead to the deployment of Webb's solar array.
Yep. At 6 minutes after separation. We should see those. Oh, already. I guess we're seeing them already?
And down in the fishbowl where there is jubilation, let's go to Raphael Chevrier of Arianespace. And before we do that, Raphael, a bit earlier than planned, but there is the solar array having been deployed. James Webb now has its array out as we stand by for confirmation that it is power positive.
Sweet.
Hey, Rob. J'entends pas ce qu'il me dit, Rob. Il m'a appelé ou pas? Il m'a appelé ou pas, Rob?
Non, il t'a pas appelé.
And there it is. There's your critical call. James Webb not only has legs, but it has power as it begins its journey and the commissioning activities to follow. And with that, let's go down to the floor in the fishbowl and Raphael Chevrier of Arianespace.
This is it. We have witnessed and the confirmation that Ariane 5 has safely delivered Webb into space. The upper stage is now being placed on a safe escape orbit around the Sun, but honestly, I've got to tell you that these images are absolutely incredible, and well, it may be the end of the mission for Arianespace, but it's only the beginning of the journey for Webb. It's now on its way to the Lagrange point. Congratulations to all the team involved in the flight. Really, there is no words to describe the immersion that is happening right now in the fishbowl. So all I can say is good luck, Webb, and bring us incredible data from the deep universe.
At that point, our sequence will continue.
Well, Raphael, congratulations on a perfect ride to orbit from the Ariane 5 out of Kourou here today. A view here in the Space Telescope Science Institute. Their work just beginning on a new era of scientific observations. Luce Fabregat, it was a smooth ride to orbit. Everything went by the book, almost like a simulation, without any problems. And we thank you for all of your insights.
So this is a really good question here from one computer guy here. Can you explain the orbit they're using? From the renders they had up throughout the process, it seemed the orbit was an escaped orbit instead of a geostationary one. It's basically an escape orbit. So just to explain here, a geostationary orbit is an orbit that orbits the Earth once every 24 hours. That's cool. He's showing a picture of his family on Christmas. Oh, that's sweet. I like that. Yeah, think about all these families and that are away, all these people that are away from their families on during the holidays, right now. I imagine I'm sure there's no other place they'd rather be right now, but, and I'm sure their families are understanding and watching and cheering too, but, yeah, just keep them in your thoughts that, they are working on a holiday right now, but what a special holiday. I mean, honestly, I can't even imagine. But okay, so the orbit. So geostationary orbit is one that orbits the Earth every 24 hours in unison with the rotation of the Earth. So it ends up looking like a stationary object. And that's about, I'm going to forget off the top of my head, something like 400 kilometers away, right? Can someone remind me what the exact orbital distance is? There's a perfect moment where, a certain altitude where if you're at that altitude, you will orbit once every 24 hours. I believe it's about 380 or something, or 400 kilometers. 400,000 kilometers. Yeah, 400,000, something like that. 36, there it is, 36,000 kilometers. Okay, way off. 36,000 kilometers, there we go. That's geostationary orbit. This is going out beyond a 1.6 million kilometers. So, yeah, it's substantially further out. It's basically at escape trajectory. Like, it's just shy of escape trajectory. And then what's happening is it's getting... it's going to the point of where its orbit gets raised exactly opposite of the sun. So it's peak orbit where it's basically going to stop, because don't forget, an orbit is fastest at the lowest point and slowest at the highest point. So it's going up there, and they just had to insert it up there perfectly so that it's like going so slow, and once they get up to the very top, they basically just tap the brakes for just a tiny, just go with a little tiny burn, and that'll park them right there. And what's going to happen is the gravitational pull of both the Earth and the sun will keep them at this orbit. And this orbit is 1 point something million miles away, or something around 2 million kilometers away. And it's going to stay in sync there because the Earth and the sun are both pulling on it equally. And it'll kind of be in this little halo orbit, just going around where the sun, it'll basically always be blocked, more or less, not directly blocked. But the Earth will always be between it and the sun. And it's just this nice stable orbit, and it's really, really, really cool. So, yeah, I'm really excited for that. So, all right. I think that's going to do it for me. Yeah, guys, I'm going to head out. I'm going to be staying in touch with this all day as things occur. Let's see. So don't forget, guys, I will be having a lot of stuff coming out here in the next week as my Christmas present to you now that the Soviet rocket engine video is done. If you haven't seen the Soviet rocket engine video and you're home for the holidays looking for stuff to do, please give it a watch. It was a complete labor of love, 2 years in the making, 4 months of just like straight editing. So finally, now that that's done, you can tell I might be like breathing better and like excited about things. Hence, we're putting out 3 videos here in the next week, basically. So stay tuned. There's a lot of really fun stuff. I'm running on all cylinders now that stuff is over. So I hope that you guys are as excited for that as I am. Yeah, I'm trying to think of what else is there to do here, guys, besides go celebrate. I mean, this is an awesome day. I'm really excited for this. This is obviously one of the biggest days in spaceflight history. I'm glad that you guys tuned in to watch with me. That really means the world to me. Thank you so much to everyone that did super chats and all that stuff. Don't forget, I will have the Astro Awards coming up here. If you guys want to support what I do, consider becoming a Patreon member or a YouTube member. That, of course, helps me. And we're coming up on a crazy launch campaign for Super Heavy. I'm going to be going down in January, and we're going to be to continuing to build out that studio to be an actual legitimate studio for you guys so that we have the ultimate 4K coverage on launch day of Super Heavy, of the world's biggest, most powerful rocket to ever fly. We will be covering it in the highest quality humanly possible, literally on par with SpaceX, and we'll be able to cover it for you guys all day. So get ready for that, guys. I promise that'll be worth it. Also, as my gift to you, our entire web store today is 10% off if you use coupon code LAUNCHDAY. All one word, all lowercase at checkout. We got a lot of new stuff, including our new Soviet collection with the RD-171 shirts, the R7 shirt, the new Space Shuttle hoodie, which, by the way, has green strings. When we shot this on model, it had the stock strings. They have actually really cool green strings. And then also, we also have a new, in our schematics collection, we also have a new RS-25 shirt as well. So if you guys want to help support me and continue to do what I do, head over to everydayastronaut.com/shop. We are not shipping through the rest of the year, so just give them some patience. It won't be heading out of the shop for at least like a week or 10 days. So yeah, if you guys want, again, all one word, all lowercase, launch day. That definitely helps me do what I do. And it's just a fun way to be nerdy. Oh, by the way, I wanted to share this because people didn't realize this, why there's these patches on this hoodie. The hoodie has all these cool patches because it's a replica of the S-1030A, the original Space Shuttle ejection suit hoodie. So this was what they wore on the first four Space Shuttle missions where they had the ejection seats. They used this. It was basically an SR-71 suit modified for the Space Shuttle. So we made it like our own version of it, and I think it's really cool and really nerdy and really fun. So yeah. So that's probably the coolest thing in our shop, in my opinion, right now. But yeah, thank you guys so much. It really, again, means the world to me that you all joined in with me this morning. Huge thank you for all of you this year for hanging out with me, for your patience and support and understanding as I worked on the Soviet rocket video and just about lost my mind doing that. I'm really excited for 2022. There's a lot of incredible stuff in the works. I'm already just like steamrolling through stuff, so I can't wait to share with you guys. And thank you to my team, to the mods, to the YouTube mods, our website crew, people that have been writing articles and doing just an awesome job with that. I just want to take a second and share a genuine appreciation for everyone that's helped. My merch designer, Allie, who does all of the merchandise. She's incredible, best graphic designer in the world, in my opinion. Gravity Coast is her company, grvtycoast.com. Just incredible. Andrew, who helps edit and do all the live stream stuff. Flo, who operates and manages the web crew. And just everyone else that helps. And the Discord community that, again, keeps me sane. Thank you. Thank you for hanging out. And this past year was amazing. This is the perfect cherry on the top for the end of the year. Is the successful launch of James Webb Space Telescope is finally in space. It's finally in space. It's going to finally be doing science here relatively soon, hopefully. So just, yeah, all the love in the world. Happy holidays. Merry Christmas. Lots more to come. So get ready, guys. Get a big old fat smile on your face today and just get excited for the future because there's a lot of really cool stuff happening. So, all right, everybody. Thank you so much for hanging out with me today. That's going to do it for me. I'm Tim Dodd, the Everyday Astronaut, bringing space down to Earth for everyday people. Goodbye, everybody. Goodbye, James Webb. See you out at L2, and congratulations to the teams involved. Amazing. Amazing. Goodbye.
It is midday at the Baikonur Cosmodrome in Kazakhstan, where an American astronaut and 2 Russian cosmonauts are sitting atop the 160-foot-tall Soyuz booster, ready to launch about an hour from now at 2:42 a.m. Central Time, 7:42 GMT, 12:42 p.m. over in Baikonur. This is a live view of that Soyuz rocket on the Site 31 launch pad in Baikonur. This is the 3rd crewed launch on the upgraded Soyuz 2.1A booster, which made its first crewed flight with the Soyuz spacecraft to the International Space Station in April of just last year. Today, a team of launch controllers are watching over all systems aboard the rocket, which at this point is fully fueled and ready for launch. We haven't tracked any issues throughout the day, which began with fuel and oxidizer loading some hours ago. They just completed a leak check on the Soyuz spacecraft, and as we speak, the 3 crew members inside are going through leak checks on their Sokol launch and entry suits. Good morning, good afternoon, good evening, wherever you are in the world. From the International Space Station Flight Control Room, this is Mission Control Houston. I'm Dan Hewitt. I'll be taking you throughout the Soyuz launch and its flight to the International Space Station later on this morning. Here inside the room, flight controllers are looking over the systems on board as they prepare for the arrival of 3 new crew members flying up on the Soyuz MS-18. The Soyuz population is going to be increasing from 7 to 10 for a few days, with the addition of NASA astronaut Mark Vande Hei, Russian cosmonaut Pyotr Dubrov, and Russian cosmonaut and Soyuz commander Oleg Novitsky. These 3 are about to begin their planned 2-orbit flight to the station, with the docking scheduled a little more than 3 hours, about 3 hours and 25 minutes after launch at 6:07 a.m. Central Time, 11:07 GMT, 4:07 p.m. in Baikonur, where we have NASA and Roscosmos support teams and officials watching the events unfold. Soyuz MS-18 spacecraft is going to be docking with the Rassvet module. It's on the nadir, or the Earth-facing side of the Russian segment, just under the Zarya module. You can see in this graphic here, we're going to have 4 Russian vehicles attached to the station just a few hours from now. The Soyuz MS-18, the one currently on the pad and bound for the station. And they're going to join the 7 current station residents on board, starting off with NASA astronaut Kate Rubins, Russian cosmonaut Sergei Kuchverchkov, and Russian cosmonaut and Soyuz commander Sergei Ryzhikov. They've been on board since they arrived in the Soyuz MS-17 last October. And also on board right now are the 4 SpaceX Dragon Crew 1 astronauts who've been on board the station since November. And that's 3 NASA astronauts, Shannon Walker, Victor Glover, and the Crew 1 commander, Mike Hopkins, and they were joined by JAXA astronaut Soichi Noguchi. Shannon Walker is going to be taking over as the Expedition 65 station commander. The change of command ceremony coming up on April 15th, a little over a day prior to Rubins, Kuchverkov, and Ryzhikov undocking from the station and returning to Earth aboard their Soyuz spacecraft. Here in Houston, Team in Mission Control is going to be monitoring today's launch, getting updates on the flight from their Russian counterparts. Flight Director Paul Kanya is going to be leading the teams for launch and through the first hours of the Soyuz flight. And the Capcom right now is Andreas Mogensen, Andy Mogensen from the European Space Agency. During the Soyuz's climb to orbit, tracking and telemetry is downlinked to ground stations along the flight path, and all of it gets routed here to the Russian Mission Control Center in Korolyov, just outside of Moscow. We'll be seeing a lot of this room over the next couple of hours. And as we will be with you for the next couple of hours, if you have any questions about today's launch, the docking, the rendezvous, anything about the International Space Station that you want to ask us, hop on Twitter, use the hashtag AskNASA, and I'll do my best to get through as many of those as we can today. Today's launch is marking the 2nd flight into space for NASA astronaut Mark Vande Hei. This is going to be the first for cosmonaut Pyotr Dubrov. He's on the right there. And then this is going to be the 3rd space flight for the MS-18 commander and Russian cosmonaut Oleg Novitsky. This expedition also going to be celebrating the anniversary of a very important milestone in human spaceflight history. and he was the first. On April 12, 1961, Yuri Gagarin became the first human to make that slow trek to the top end of a rocket bound to hurl him into the heavens and into the distant frontier of space. And it was a trip into the most unknown of unknowns.
Wishing you a good flight. Copy, good flight.
Riding on technology still in its nascent stages, until this point developed in the throes of conflict, Yuri took to the skies, ascending into orbit for 108 minutes of history. And then after hurtling back through the Earth's atmosphere, Yuri ejected from his space harbinger and parachuted down to the Kazakh steppe. At that moment, he was transformed into a hero for the Soviet Union and the forerunner for humankind's ventures into outer space. And though he was taken from us too soon, those that look to slip the bonds of gravity and reach beyond a terrestrial home will forever revere what he accomplished. For once again, Yuri was the first. The Expedition 65 cruise Soyuz launch is going to honor the anniversary of Gagarin's historic flight with a mission patch adorning the fairing of their launch vehicle. The design of the Soyuz MS-18 patch incorporates a banner depicting the years 1961 and 2021, flanking the number 60, symbolizing the 60th anniversary of human spaceflight. But right now on board the Soyuz today is a NASA astronaut. He's making his second long-duration flight to the space station. So let's kick things off by learning a little bit more about Mark Vande Hei.
So arriving at the space station, something I'll never forget is looking over my left shoulder out the window in the Soyuz, where it was either a view of the Earth or blackness of space. And then all of a sudden I could see a solar array. Getting chills even thinking about it right now. It was this beautiful gold, massive. I mean, you don't ever train and see a solar array at full scale here. And so there it was, and the Russian commander sitting to my right. I had to really pay close attention, and I was supposed to be too. But as soon as I saw those solar rays, I broke the silence. I said, "Wow!" And he was like, "So yeah, I was definitely a rookie. I was excited." The freedom of motion inside of the space station is huge. And then working was busy. It was definitely very busy. I got up there when a SpaceX Dragon spacecraft was docked, just because there's a lot of science that requires return and things have to be done in a very specific timeline. It was very fast-paced immediately. And the space station is very unique because on the space station, orbit is really a continuous freefall. And because of that, you can have some very unstable structures that might not be able to stay together if you're on the ground. They can stay together on the space station. Flames behave differently because combustion on the ground requires drawing in all these rich gases into the flame because the hot combustion gases go up and away. But there's no up and away on the space station. All directions are equal as far as that's concerned. So that behaves differently. There's all kinds of different phenomena that we can experiment with. That's why it's a wonderful laboratory. Many, many different experiments. Some of those experiments actually have to do with us as the test subjects, because we're trying to understand how to have people safely travel for longer and longer distances too. That's just a sub-part of all the science we're doing on the space station. Some people have talked about at some point in the expedition feeling like it's time to go home, but for me there was always another spacewalk or another vehicle capture that was coming up, so it always felt like suddenly I was going home, and it surprised me. I'm Mark Vande Hei, and I'm a NASA astronaut.
And Mark is just one of the three flying into space today, so now let's dive in and meet our entire crew. Born in Virginia, then raised in New Jersey and Minnesota, Mark Vande Hei earned a Bachelor of Science in Physics from St. John's University and a Master of Science in Applied Physics from Stanford University. He was commissioned in the U.S. Army through the ROTC program and served as a combat engineer. In 1999, he became an assistant professor of physics at the United States Military Academy in West Point. Vande Hei reported to the Johnson Space Center in Houston in July 2006 to serve as a capsule communicator or CAPCOM in mission control. Selected in June 2009 as one of 9 members of the 20th NASA astronaut class, Vande Hei first launched to the space station aboard Soyuz MS-06 on September 13, 2017. Serving as a flight engineer during Expeditions 53 and 54, he conducted 4 spacewalks, spending a total of 26 hours and 42 minutes outside the space station. During his mission, the crew marked the beginning of the first long-term increase in crew size on the U.S. segment, enabling NASA to double the time dedicated to research and achieve a record-setting 100 hours of research in 1 week. So far, Vande Hei has logged a total of 168 days in space. And Mark Vande Hei is a flight engineer for today's launch. He's seated to the right of the Soyuz commander, Roscosmos cosmonaut Oleg Novitsky. Born in Cherven in the Minsk region of Belarusia, Oleg Novitsky attended military pilot school and became certified as a pilot engineer. He went on to graduate from the Yuri Gagarin Air Force Academy and earned a master's degree in state and municipal administration from the Russian Presidential Academy of National Economy and Public Administration. Before becoming a cosmonaut, he was a qualified paratrooper instructor, a military diver, and a Class II military pilot with a total of 700 hours of flight time. Selected as a cosmonaut candidate in 2007, Novitsky qualified as a test cosmonaut in 2009. His first space flight was as Soyuz TMA-06M commander and a flight engineer during Expeditions 33 and 34. His second flight to space was aboard Soyuz MS-03, where he served again as a Soyuz commander and a flight engineer for Expeditions 50 and 51. While aboard the space station, he supported arrivals of multiple cargo vehicles and performed science experiments to the Russian ISS research program. Novitsky has a combined total of over 339 days in space. Oleg Novitsky is serving as the Soyuz MS-18 commander and will serve aboard the International Space Station as an Expedition 65 flight engineer. And seated to his left is first-time flyer Roscosmos cosmonaut Pyotr Dubrov. Born in Khabarovsk, Russia, Pyotr Dubrov graduated from the School of Information Technologies and continued his studies at the Khabarovsk State Technical University, graduating with a specialty in software for computing machines and automated systems. Dubrov also studied and received his Master of Sports in Parachute Jumping, and his early career included serving as a software engineer at the Khabarovsk Railways, at Dalcom Bank, and at Seaboss Development International. Beginning his cosmonaut training in 2012, Dubrov was certified as a test cosmonaut in July 2014. Assigned to his first space flight as a member of the Expedition 64-65 crew, he will serve as a flight engineer aboard Soyuz MS-18 and on the space station. And we're back now with a quick live look inside the capsule. You can see the commander there in the center seat, Oleg Novitsky, and at the top of your screen is Pyotr Dubrov in the left seat today. And just a reminder, a little bit later in the program, we'll be taking your questions, so hop over to Twitter, use the hashtag AskNASA, and keep sending those in. Continue on, though, something you'll see inside the cabin. Before departing the Gagarin Cosmonaut Training Center in Star City, Russia, the commander Oleg Novitsky was able to describe his inspiration for the selection of the crew's zero-G indicator. We have a quick clip of that.
For the weightlessness indicator, I do have it with me. This is one of the heroes of our nice cartoon, Kitten Gaff. Yes, it is him. Especially this year, I believe it has been 40 years since this cartoon came out. And the story is that the puppy is waiting at home for the kitten that is flying in space.
And here's a closer look at Gav, or Woof the Kitten, star of the Russian animated series made from 1976 to 1982 about a Siamese kitten. And you will see that floating just in front of the commander's chair, right in front of Oleg, and we'll see that float once they separate from the third stage of the Soyuz rocket and enter into microgravity. But continuing to get views inside the capsule and of the Soyuz rocket on the launch pad there in Baikonur. We're going to continue to check in on Mark Vande Hei, Oleg Novitsky, and Pyotr Dubrov as they get ready to launch to the International Space Station. And right now we are 41 minutes and 30 seconds away. Launch is timed to take place at exactly 2:42 and 41 seconds Central. That's 7:42 and 41 seconds GMT, or 12:42 and 41 seconds over in Baikonur. And as I said, we're going to be answering some of your questions, so let's go ahead and start taking a couple of those now. And you can keep sending them in using the hashtag AskNASA. Our first one comes from Kate, who wanted to know, how long can the station provide life support to more than 7 astronauts at once? That's a really great question, Kate. We don't have a specific amount of time. This is going to be a handover with 10 people on board, so that does put a little bit more of a strain on your resources, but thankfully we have what we call regenerative life support, so we're able to recycle a lot of the oxygen. We actually generate oxygen from water, which we have more than enough on board the space station, and then you have other life support responsible for scrubbing carbon dioxide and also providing drinking water, and we have enough food and other consumables on board to last for several months. And so more than enough on board to keep these 10 crew members going for a couple of days. And also we'll have plenty when we do the Crew 2, Crew 1 handover, where we'll bump all the way up to 11 on board for a couple of days. Our next question comes from Whitney, who said, silly question, but wanted to know, how many flight suits do they give you? And do you ever actually use all of those pockets? Happy launch day. It's going to differ for the astronauts. They do get a couple, just in case any get damaged or dirty. And I will tell you from personal experience, you do end up using a lot of those pockets, and you also end up forgetting stuff in those pockets, only to find it several months later when you put the flight suit back on. All right, and we'll do one more, at least one more. This one from Chrissy, who wanted to know, what will the sleeping arrangements be on the station with 10 people? And we get this question a lot. So right now we have 7 crew quarters, the individual sleep stations for crew members on board the space station. We just installed a new one just this week inside of the Columbus module. So with the extra 3, they do what's essentially called a camp out. They find space in the different modules where they'll set up a temporary spot where they can attach their sleeping bag to the wall, and they just kind of camp out there for a couple of days. The crew on board works with flight controllers here on the ground to pick those spots, to give the astronauts as much privacy as possible when they don't have their own crew quarters, and it is just temporary. Our next one comes from Alejandro, wants to know how much gravity the astronauts have during takeoff. So how many G's are they pulling? With the Soyuz, it's a fairly benign ride uphill. They'll pull about 3 or 4 G's at a maximum on the way up, primarily once they're under the power of that second and third stage. So not too bad. They typically pull a little bit more on the way home, but the ride up pretty smooth, with those liquid fueled boosters powering them up the whole way. And we'll go ahead and take one more. This one from Get Well Wickens. He wants to know, is the Soyuz rocket a one-time use, or are there reusable parts? The rocket itself is a one-time use. It's an expendable. So all of these different rocket parts will either fall to the ground in the vast expanse of Kazakhstan, or in some of the cases, like the very upper stage, burn up upon re-entry in the Earth's atmosphere. But keep sending those questions. So now we're giving you some video here. This is from yesterday, where Russian Orthodox priests did the traditional blessing of the rocket. And this is done prior to every single flight, blessing of the rocket, and then it typically will do a blessing of some of the pad engineers and some of the other officials, and then moving over to give the media a quick blessing as well. Today's activities in Baikonur, though, began several hours ago as the crew was woken up in the Cosmonaut Hotel in Baikonur.
There is room here.
In a time-honored tradition, as you can see our commander doing here before departing, the 3 crew members signed the door of the rooms they occupied at the Cosmonaut Hotel.
It's looking good.
For Nowitzki, this was his 3rd time signing. For Dubrov, his first, as he's the rookie amongst the crew. And then Mark Van High about to make his 2nd flight aboard a Soyuz spacecraft and to the International Space Station. This was his 2nd time signing a door inside the Cosmonaut Hotel. They were woken up at about 3:05 a.m. local time over in Baikonur. It was about 5:05 p.m. Central Time here in Houston, or 22:05 GMT.
Okay, follow me now. This way.
And then just about 3 hours after waking up, the crew departed the Cosmonaut Hotel. You can see 6 flight suits there, so the prime crew in front, the backup crew behind them. That's NASA astronaut Anne McClain, Russian cosmonaut Anton Shkaplerov, and another Russian cosmonaut Oleg Artemyev. The backup crew stays in quarantine with the prime crew throughout their stay in the Cosmonaut Hotel and their final time in Russia beforehand. And they're with them as they go through their final suit up and rides out to the pad. Again, another time-honored tradition of flying aboard the Soyuz, the Russian Orthodox priest blessing the crew as they make their way out of the hotel and get ready to board a bus and head over to get their suits on.
That's enough water.
And so after a quick shower, they wave farewell to those that are gathered at the hotel, pose for a few final photos, and then board the bus. And then they are bound for what's known as Building 254, or the Suit Up and Integration Building. The Cosmonaut Hotel on the very edge of the town of Baikonur, just outside of the Cosmodrome grounds proper. It's about a 40-minute ride from their hotel out to the Suit Up building. And all of this happening about 3 hours after they woke up, about 6:05 in the morning. So an early morning for everybody there in Baikonur.
Good morning. Good morning to everyone. This is good.
And so once they arrived at the Integration and Suit Up facility, Building 254, the crew underwent some final medical exams and then suited up in their SOCA launch and entry suits. They're in these throughout all of the dynamic phases of flight, so they're essentially wearing these in their very quick about 3-hour and 25-minute journey up to the space station, so they're wearing them now all the way until they arrive. And these SOCA launch and entry suits are primarily worn if you're familiar with a lot of the different space vehicles. You're wearing these suits during the ride, and they're there to protect you in the event of what's called a cabin depressurization. So if for whatever reason a spacecraft were to lose the integrity of its hull, if the cabin were to go down to vacuum, these suits are connected to breathing air and can pressurize to protect the crew in the event that something like that happens. And that's why we have them wear these throughout all of what we call the dynamic phases, so things like a launch, or anytime you're rendezvousing, docking, undocking, and then coming home, the crew members will be wearing these suits. The small blue knob you can see right at the top part of the chest is used to adjust the pressure once they go through the inflation or the pressurization of the suit itself. And after they get suited up, and we'll see it in just a moment, each of the crew members goes and gets a quick pressure check or a leak check on these suits, and so we'll be able to see them inflate a bit. But again, for Mark Van de Heij, this is the second time he's done this exact same process. Again, so after they get the suits on, they move over to get a pressure check, just again to make sure that the suit is free from leaks. They each get into basically a mock-up of a Soyuz seat, so what you're looking at is what it looks like once they're inside the capsule itself. They're assisted by suit techs who then connect their suits to a simulated line to pressurize the suit and start flowing breathing air throughout it. And so you'll see once they get locked in, the suits will kind of puff up, and that's how you can know that they're pressurized. It's easier to see if you pay attention around the leg area, and you'll see everything looks a little bit puffier. And again, the crew goes through this one at a time. While all this is happening, and we'll see it in just a few moments, there's a pane of glass to help maintain that strict quarantine. That's true for all crew members spending long-duration flights on board the space station. It's not something that we've implemented just in the last year in the current pandemic climate. Quarantine has been standard for crew members bound for the International Space Station for many years, as they're essentially launching into a closed environment, and one of the negative effects of living in microgravity for a long time can actually suppress your immune system. And so we want to make sure crew members are as healthy as possible, not bringing any cold bugs or anything like that up there with them, so they're kept in a very strict quarantine. Access to the crew is extremely limited in this time. And it's typically about the 2 weeks right before they lift off. This is the same for crew members flying on a Soyuz spacecraft. It's the same that we've been putting crew members for that have flown up on the SpaceX Dragon in the last, in the Demo 2 and the Crew 1 flights. And then once their suits were confirmed to be leak-free,
we became very close to you, to the whole crew. And we're always here to support you if you need us. It's the most important thing to remember that. According to the evaluation of readiness for launch, the rocket and the boosters are in good technical condition. Everything is working nominally, and I wish you successful completion of your mission. I know you have done everything that has to be done during your preparation stage, and will continue talking to you via Mission Control Center. Your program will be a little bit more full than for previous crews. You will not be bored. Hopefully you will find some time to rest. And of course, continue supporting each other and stay good friends.
I want to wish you all the best, and I want you to know that we're very, very proud of you, the whole crew, and know you'll have a great mission.
It's been a pleasure watching you guys get ready for this mission. We're looking forward to seeing you on orbit, and you have people across the globe waiting to support you on anything you need. So thank you very much.
And again, so they were able to talk to a number of folks inside after confirming their suits were leak-free, speaking with Sergei Korsakov, a cosmonaut who was assigned to the flight up until the swap for Mark Vande Hei, also speaking to Dmitry Rogozin and Sergei Krikalev from Roscosmos, and Ken Bowersox and Joel Montalbano of NASA. After that, though, they were able to board their bus. That happened right at about 8:56 a.m. Friday morning in Baikonur for the ride out to Launch Pad 31. And Launchpad 31 a little bit further away than Gagarin's start, where for years crews have launched from Baikonur to the International Space Station. It took them about 70 minutes to get over to the pad. The crew members being helped again in those SOCA launch and entry suits to make their way to the rocket, head up the elevator for their ride to space. And then once at the pad, the crew climbing a small flight of stairs, getting set up, taking a few final photos and waving goodbye to officials from Roscosmos and NASA gathered to see the crew members off before they head into the elevator for the ride up to the top of the Soyuz rocket to board their capsule. This all took place about 2 hours ago, and since then the crew has been in their seats. Again, Oleg Novitsky is in the center seat. He's the commander of the Soyuz spacecraft. Pyotr Dubrov in the left seat, Mark Vande Hei in the right. Since they've been on board, they've gone through a number of pre-launch checks, confirming good leak check on the Soyuz capsule itself, also doing leak checks on their suits, continuing to speak with the pad engineers and the launch teams down in Baikonur as they continue to count down towards launch. Back now, though, with a live view of that Soyuz, the MS-18 spacecraft, and the Soyuz rocket on the launch pad in Baikonur. And if you're just now joining us, a reminder, liftoff is scheduled at 2:42 a.m. Central Time. That's 7:42 GMT, or 12:42 p.m. over in Baikonur. And as of right now, we are 22 minutes and 5 seconds away from that launch. And as we continue to count down, let's first explore the Soyuz spacecraft in a little bit more detail.
The whole Soyuz spacecraft is 24.5 feet long with an overall volume of 177 cubic feet and comprised of 3 modules. The descent module, situated in the middle of the Soyuz vehicle, contains customized seats for the crew members during launch, entry, and landing, and contains all the controls and displays necessary for the flight. It also houses life support systems, batteries for the re-entry and landing, and the parachute and soft landing rocket engines that slow the Soyuz just before touchdown as the spacecraft lands in Kazakhstan. There are 8 hydrogen peroxide thrusters located on the module, which are used to control the spacecraft's orientation, or attitude, during the descent until parachute deployment. The descent module also contains a guidance, navigation, and control system used to maneuver the vehicle during the descent phase of the mission. This descent module is 7.3 feet long with a diameter of 7.1 feet and a habitable volume of 124 cubic feet. It is the only portion of the Soyuz that survives the return to Earth. The orbital module at the top is 9.8 feet long. It connects to the descent module via a pressurized hatch. This is where the crew has a small amount of room to move around following launch during the flight to the space station. It has a docking mechanism, hatch, and rendezvous antennas located at the front end. The docking mechanism is used to dock with the space station, and the hatch allows entry into the orbiting complex. The rendezvous antennas are used by the automated docking system, which uses radar, to maneuver toward the station for docking. There is also a forward-looking window in the module that the crew can use to take manual measurements of distance and closing speed with a laser rangefinder in the event of failure of the rendezvous radar system. The propulsion module houses the oxygen storage tanks, the main engine, and the attitude control thrusters, avionics, and communication and control equipment. The propulsion portion of this module handles all orbital maneuvers, including those needed for the rendezvous with the space station and the deorbit burn at the end of the spacecraft's mission. Before they are deployed, the 2 solar arrays are folded against the body of the propulsion module, which, along with the orbital module, separates from the descent module after the deorbit burn. The solar panels span almost 35 feet. The entire spacecraft serves not only as a crew transport vehicle to and from the space station, but also as an emergency return vehicle in the unlikely event the crew needs to leave the station unexpectedly.
And we'll be going through this Soyuz spacecraft in a little bit more detail as we continue to watch it fly up to the International Space Station. For now, though, let's take a couple of moments. If you have any questions about the launch or the flight today or anything about the space station, jump onto Twitter, use the hashtag AskNASA, and we will try and knock out as many of these as we can this morning. So let's do a few more. This first one up from Tristan wanted to know what are the main things to look for in order to have a successful launch. It's a great question. So this is essentially a 3-stage flight to orbit today. The whole thing over in just under 9 minutes. We'll look for a couple of key events. I'll outline those for you real quick. So about 1 minute 54 seconds into flight, the launch escape tower will jettison. If you look at this view of the rocket, it's the very narrow part at the very top. That's in place to detach and pull the capsule away from the rocket in the event there's any issue on the way uphill. That will detach at 1 minute 54 seconds, and just 4 seconds later, the first stage will separate. Now, the first stage on the Soyuz spacecraft are 4 strap-on boosters on the very bottom. They're firing along with the second stage for about the first 2 minutes into flight. Shortly after that, about 30 seconds later, the launch shroud, so the white part of the rocket just below the launch escape tower, that will break off, and that will unveil essentially the Soyuz spacecraft to the vacuum of space. That's there to protect it in the denser parts of Earth's atmosphere as the rocket climbs uphill. The second stage will shut down 4 minutes 37 seconds into flight, and then it'll separate at 4 minutes and 48 seconds. After that, the lower skirt of the third stage will jettison, and that will continue to fire until just before 9 minutes into flight. And so we're really looking for all of those different staging events to take place, and then we're going to look for what's called a good orbital insertion. That'll be the primary thing we want to hear at the very end of the ascent. All right, our next question comes from Brian, who wanted to know, will the launch be occurring at the time the space station passes over the launch site like it does from the Cape? It's a little bit different for this one, as it's timed extremely specifically in order for the Soyuz to make this this kind of fast track to orbit rendezvous. At the time of the launch, the station will be about 259 miles over northern Uzbekistan. It'll be about 335 miles behind the Soyuz as it leaves the launch pad. But then during that ascent, space station will actually leapfrog in front of the Soyuz during the climb to orbit. So when the Soyuz launches, station will be a little bit behind it, but by the time Soyuz hits orbit, station will be a little bit in front of it. That's a great question, but it is timed extremely specifically so they can make this quick to orbit, about 3-hour, 25-minute rendezvous. Our next question comes from Blockbuster. Wants to know, what is the docking in English time? I'm assuming you mean UTC or Greenwich Mean Time. That is a great question, and that's a pretty easy answer because that's the same time that we use on board the International Space Station. Docking today is scheduled to take place at 11:07 and 51 seconds GMT. It's the same time zone that they use on board the space station and that we follow at all of the different flight control rooms around the world just to stay in sync. Our next question comes from Nick, who wanted to know which 3 Russian vehicles are already docked to the station and what is the station's maximum crew capacity during crew rotation. Well, there are 3 other Russian spacecraft currently docked to the station. 2 of them are Progress or cargo spacecraft, and 1 is another crewed vehicle. We have the Progress 75 and 77 docked to the Earth-facing port on Zvezda, and also the very aft, or the very back part of station. And the Soyuz MS-17, which carried Kate Rubins and her Russian cosmonaut colleagues up to the space station about 6 months ago, is already docked. And then pretty soon at the Rossviet module, or the mini research module number 1, in about 2.5 hours, or about 3.5 hours after launch, we'll have the Soyuz MS-18 spacecraft. The most we've had before, when we were doing these handovers, was about 9, and we're going to have 10 when we have 2 Soyuz spacecraft and the Crew 1 Dragon attached. We'll go up to 11, and that's expected to be about the max that we'll see for these crew handover periods in the future. That'll happen anytime we do what's called a direct handover, when a new crew launches and arrives at the International Space Station before another crew leaves. All right, our next question comes from Chris Davies. Wants to know, is there any plans to have a Russian join a Crew Dragon flight at this stage to return the favor for the many years of Americans on Soyuz? Great question, Chris, and there absolutely is. It's fully our intention to fly what we call mixed crews, so having at least an American and a Russian on every spacecraft going to the International Space Station. The Russian cosmonauts receive much more extensive training and have a lot more expertise on the Russian segment, which is functionally 1/2 of the International Space Station. And the same is true for American astronauts and the U.S. segment. So to just put us in the best possible posture to continue operating the space station safely, and just have really the best people always on hand for the job, we fully intend to see our Russian counterparts join us pretty soon on the U.S. commercial crew vehicles that are currently flying to the space station, like the Crew 1 currently docked. All right, let's do one more for right now. This one comes from Dean, who wants to know, does Soyuz also use RP-1 as fuel? And does he use the same oxidizer that Falcon 9 used to launch Crew 1? It's extremely similar. It is essentially RP-1, which is just a refined form of kerosene that's very commonly used in a lot of rocket engines. There are some slight differences between the refining process, between the fuel used in the Russian spacecraft and in the Falcon 9 in America, but for most purposes they're essentially the same, and they both use the same oxidizer, liquid oxygen. The RP-1 and the liquid oxygen is used for all 3 stages of the Soyuz launch vehicle. The Soyuz spacecraft itself uses what's called hypergol fuels, or fuels that don't need an ignition source for all of its maneuvers once it reaches on orbit. That'll do it for now for our questions. If you have any more, remember to keep on getting over to Twitter. Use that hashtag AskNASA. We'll get through a few more in the launch show, and then we'll get through a whole bunch once we're on orbit for a rendezvous and docking. But for now, continuing with our live coverage of launch, Mark Vande Hei, Oleg Novitsky, and Pyotr Dubrov to the International Space Station, getting great views of the Soyuz on the launch pad, and it's clear skies, so should have a great view for launch today. As of right now, we are just 11 minutes and 11 seconds away from liftoff. Again, that's timed for 2:42 a.m. Central Time, 2:42 and 41 seconds to be exact, 12:42 and 41 seconds over there in Baikonur. The spacecraft was mated to its booster, and the 3 stages were joined together earlier this week on Monday. Then just 24 hours later on Tuesday, the rocket began its trek to the launch pad, taking off right at about 7 a.m. Baikonur time, then arriving less than 2 hours later, where it was raised to its vertical position for the final pre-launch preparations. As of right now, it's poised for launch with the 3 crew members aboard. The Soyuz spacecraft sits high above those 3 different stages that we walked through a little bit earlier, which uses that kerosene or RP-1 and liquid oxygen as the propellant. For now, though, why don't we take a little bit deeper dive into the Soyuz booster itself.
The Soyuz rocket stands 162 feet tall, weighs about 640,000 pounds, and consists of the Soyuz spacecraft inside a protective shroud at the top and the 3-stage Soyuz 2.1A booster below. The first stage has 4 liquid engines strapped to the side of the core vehicle. Each will burn for 1 minute and 58 seconds before they drop away. The core engine of the first stage also serves as the second stage and continues to burn until 4 minutes and 57 seconds into the flight. The third stage has a single engine that will ignite before the separation of the second stage, helping to push it away safely. It will burn until the 8 minutes and 46 seconds mark of the flight, and at that point the Soyuz spacecraft will separate from the third stage, having arrived at its preliminary orbit.
And continuing to get a look at that Soyuz rocket on the pad, again launching from Site 31 at the Baikonur Cosmodrome in Kazakhstan. We're under 10 minutes away. We're just 9 minutes, 4 seconds, 3 seconds, 2 seconds, no seconds away from launch. Continuing to march towards that 2:42 and 41 second a.m. Central Time, 7:42 and 41 seconds GMT. So we're continuing